All right, I see that it's recording on my end here, James. So just wait maybe a couple minutes here for people to roll in.
Yeah, just go ahead and if you see anybody in attendees that you want to be a panelist, just give me a heads up and I'll promote them.
Okay. Yeah, so Yumi and the attendees could be upgraded. And then Wendy, oh my God. Let's see here. Paul McGregor. And James, do the attendees have the ability to raise their hands?
Yes, they can raise their hands.
Okay. Maybe I'll do this. Those of you that are in attendee, if you're supposed to be a panelist, please raise your hand and we will upgrade you over to panelists. Right now, the most important is going to be the presenters from PG&E, SCE, and SDG&E.
So Fred, you're already a panelist. You might want to rename yourself though, Fred, because currently it's only your first name and I don't know your last name.
Yeah, and those of us that are panelists, it would be really helpful to put your organization in parentheses after your names. That way, as we get into the question and answer sessions of today's workshop, we'll be able to know what organization you represent.
All those that were on the attendee side that had their hand raised to be promoted to panelist have already been promoted.
Okay, thank you so much, James. And we'll get started. And as people are rolling in, just keep in mind, if you're supposed to be a panelist, please raise your hand and we will upgrade you over to the panelist side. Yeah, so we'll get started. So everyone, thank you for joining today. So today's workshop is going to be focused on risk spend efficiency. And to get started, I'm going to have our program and project supervisor, Susie Rose, to give an introduction. And James, go ahead and next slide, please.
Good morning, everyone. My name is Susie Rose. I am the acting program and project supervisor for the Electric Safety Policy Division of the Office of Energy Infrastructure Safety, which we call Energy Safety. As we all know, wildfires continue to be a major threat to the environmental, social, and economic well-being of the state of California. Risk spend efficiencies that we'll refer to here as RSEs may play an important role in understanding the cost effectiveness of wildfire mitigation initiatives that can help prevent catastrophic wildfires. With finite resources, electric utilities must utilize risk-based decision-making when selecting mitigation initiatives, and RSEs are an important decision-making consideration. As we saw in the electric utilities 2021 Wildfire Mitigation Plan updates, the utilities each utilize different inputs and assumptions in their RSE calculations, sometimes resulting in stark variances in RSE estimates for the same initiatives calculated by different utilities. For example, the RSE values for covered conductor installation varied by utility from a value of over 4,000 for one utility to a value of approximately 4 for another utility. The utilities do have differing service territory characteristics. However, the utilities face similar enough circumstances that there should be some level of consistency in the inputs and assumptions that utilities use to calculate RSE values. Through this workshop, we hope to increase collaboration among the utilities allow for stakeholder and academic expert input, and provide greater transparency into the inner workings of the utilities RSE calculations. At today's workshop, the utilities will each present their current inputs, assumptions, and methodology for calculating RSE values. We will also hear from a panel of stakeholders and experts who will address various topics related to RSEs. And you will all have the opportunity to ask questions along the way. With that, I will turn it back over to Alan Wu to go through the logistics and the agenda for today's workshop. And thanks for attending.
Thank you so much, Susie. And James, next slide, please. All right, so brief agenda. We're going to go through a safety message, and then we're going to go over the workshop objectives, agenda, logistics, and then also an overview of the presentations themselves. Go ahead and next slide, please. Brief safety message. Please be aware of your surroundings and remember to stay hydrated. Know the evacuation routes of your location. We do have 2 scheduled breaks as well as a lunch, so make sure to stand up and move around when appropriate, and practice public health guidances. Also, if you feel something, say something. Feel free to utilize the chat function to let us know if there is something going on, and we can send help your way. All right, next slide, please. Workshop objectives. So this workshop here has 3 main objectives. 1, understanding each utility's current RSE calculation methodology, verification process, and utilization. We're going to discuss best practices for those RSE subjects above with subject matter experts. Also, we aim to increase transparency, alignment, and stakeholder input for utilities' RSE calculations and utilizations. Next slide, please. Workshop agenda. So after the introductions, we're going to have PG&E present first, followed by SCE, and then we're going to have a brief break, and then we're going to pick up with SDG&E. Then we'll have lunch, and after lunch, we'll have our 2 Q&A sessions. The first one with the utilities regarding the presentations from this morning, and then after break, we're going to have a panelist Q&A session where we're going to ask stakeholders and subject matter experts questions for discussion, and then we're going to have closing remarks after that. Next slide, please. And workshop logistics. So please save all questions for the utilities until the Q&A sessions after lunch, and please utilize the Zoom Q&A function. We do have a chat moderator that will be keeping track of the questions. Make sure to keep the comments and questions focused on the workshop topics themselves. And also, when you are submitting questions, please clearly address who the question is directed towards. And if it's for all utilities, you can state for all utilities. All right, next slide. So presentation overview. The utilities were asked to include the following. The first is going to be an overview of the calculation methodology. And that is going to include risk reduction value determination, total cost determination, net present value determination, a walkthrough of an RSE estimate calculation from start to finish, discussion of any assumptions within the calculations themselves, and also anticipated changes to RSE calculation methodology from now until 2023 WMP. The next is going to be the verification process. Here, the utilities are going to present on the confidence values of their RSE estimates, including how those confidences were determined, a range of uncertainty for the RSE estimates, and also how those uncertainties affect the interpretation and utilization of those RSE estimates. We're also going to discuss anticipated changes to RSE verification process from now until 2023 WMP. Lastly, is going to be the RSE values and the initiative selection process. So if utilities are going to present an overview of the initiative selection process and discuss how RSE estimates are considered when selecting initiatives. And lastly, how do RSE estimates compare to other decision-making factors? And next slide, James. Perfect. So at this point here, we're going to call up the presenters from PG&E. They are going to go first. And remember, the utilities have a full hour, so please take your time and explain clearly. Thank you so much. And James, let's bring up PG&E's PowerPoint here. Thank you.
Yeah, give me a second here. Since it was, I have to bring it over here real quick. Can you tell me if you see that?
Yep, it is presenting right now. All right, PG&E, the floor is yours.
Hello, thank you for introduction. This is Yumi from PG&E's Enterprise Risk Management team, Risk Analytics team. I will be presenting a first part of the agenda in here. If you go to the next slide, we're going to cover in 3 sections. I will be talking about the RSE calculation methodology, and my colleague Devika will be talking about the second and third section. So if you go onto the next slide. So let me go over like overview of RSE calculation methodology that we currently use. Slide 4, please. Sure. So this might be familiar to a lot of you, but let me just go over like what the RSE is in a brief way. So RSE is benefit cost ratio, or representing cost effectiveness of the risk mitigation or risk reduction programs, where the benefits of those programs are risk reduction and cost is cost. So here, if the mitigation has long-term benefits, then the RSE needs to reflect full set of benefits rather than just first year's benefit. Therefore, we also need to figure out like how long the program benefits last and what risk reduction values is for each year with the benefit is, and then combine annual risk reduction values using net present value calculation so that the lifetime benefits can be accounted for in the RSE. So in the net present value calculation, we need a discount rate. PG&E uses after-tax weighted average cost of capital, which is 7% in discounting. We note that we use the same discounting rate for the numerator, the risk reduction values, as well as the denominator, which is the cost. And the reason that we do that is if the discount rate is different between numerator and denominator, the timing of the program can impact the RSE values that you may not want. And so, for example, if we delay a project, may increase the RSE if the discount rate is lower for the numerator compared to the denominator, which may not be consistent with the preference. So we use the same rate of 7%. Next slide.
Sorry, give me a second. Hold on, I'm sorry. There you go.
Thank you. So what's needed to calculate risk reduction value, which is in the numerator of the RSE portion? We can group them into like 4 areas. First, we need to define what the risk is and quantify the risk first. For the WMP, it is the risk event that we use is the wildfire risk. The event itself is CPUC reportable ignition, and we need to quantify the risk for that. And then for each of the program that we are calculating the RSEs, we need effectiveness information, and then the scope, which is about how much we do and where, and then the time, about how long the benefits will last. So I will go over how we are using this information in more detail in the following slides. So slide 6, next slide, please. This slide talks about the first part of the calculation, which is quantifying, having a quantified risk score that the mitigation is aiming to reduce the risk. So risk score is multiplication of two primary elements. One is the frequency, and the other is the consequence. So the frequency is, as the name can tell, it is number of expected number of risk event per year. So some utilities use frequency lower likelihood of risk event for frequency. We specifically just call it out as a frequency in here, and we represent it as multiplication of the two, exposure times likelihood. So for example, if the likelihood of an ignition is 0.004 events per mile per year, then the exposure is 100 miles, then the frequency of an ignition for that 100 miles is multiplication of the two, and so it's 1.5 events per year. So that's the frequency part. And then the consequence part is representation of a consequence of a risk event in a single unit, risk unit. Consequence is quantified at PG&E for safety, reliability, and financial attributes. We call these as attributes. And we combine those three attributes that's quantified for consequence of an ignition. We combine that using PG&E's multi-attribute value function, which is MAVF. We will describe in the following slide. Next slide, please. So this shows the MAVF function that we currently use to represent the consequence of a risk event in one unit. So in a nutshell, let's say attributes listed in here: safety, electric reliability, gas reliability, and financial portion is quantified. Safety is quantified in equivalent fatalities in their natural unit, and electric reliability is quantified in customer minutes interrupted. And then financial is quantified as in dollars. And then we need to combine these different units into a unit that we can compare different attributes across. So we assign the weight. The weights are used to compare the upper bound of the range. So here you can see upper range of the upper bound of the range. For safety is 100 fatalities are given 50% compared to financial $5 billion is given 25% weight. So comparing 100 fatality versus 5 billion, we are weighting 2 times more for 100 fatalities compared to 5 billion consequence. Likewise, 4 billion customer minutes interrupted is 20% weight versus 5 billion is 25% weight. So 4 billion and 4 billion customer minutes interrupted versus 5 billion consequence is 20 to 25 ratio. So approximately it's one customer minutes interrupted is weighted as 1 million, $1 financial consequence. So that weight is used for indicate the trade-offs between different attributes. And then it goes through the scaling function to put a unit into the consequence and then produce its core value. So for example, we also use in here like 1,000 scalar in the formula on the above for calculating the core value. So let me give you an example of calculation here. So let's say we have an event. The example is written here, an event in a red flag warning catastrophic outcome event that results in 13 equivalent fatality for safety attribute and 104 million customer minutes interrupted for electric reliability, and then 1.8 billion financial loss from that single deterministic event. Then it will go through this MAVF function, and then it's going to produce core value of 13,707. One another way to get a sense of what the MAVF means or what that number will mean is that, let's say if you have an event with 100 fatalities as an outcome, then it will have 100 fatalities will be equal to 100 scaled unit. And so 1,000 times 50% times 100 is the core value associated with 100 fatality, which is 50,000. For the financial wise, if you have an event of $5 billion consequence, if it goes through the same calculation, 1,000 times 25% times scaled unit of 100 gives us 25,000 in core value. Another way to think about this is that if you have 2 million risk event, 2 million loss consequence event in financial wise, it will give us 1 in core. So that's how we can try to think about the risk units into the dollars with the PG&E's MAVF. Next slide. So now we described how we calculate the risk score, like frequency times core, and core is using MAVF to combine different attributes into one single unit. In order to calculate risk reduction, we need to have risk scores. We represent, or we need to have the risk scores for each of these dimensions. So if we have a wildfire risk event, we call this as a bow tie. On the left-hand side, we have all of the drivers that could cause the risk events. It can be further broken down by sub-drivers. If desired, for wildfire risk, most of these drivers have more detailed sub-drivers. And then on the right-hand side of the bow tie, we have different outcomes an ignition event could result in. We have 10 outcomes currently to represent different level of severity when an ignition happens. And you can see that we have red flag warning versus non-red flag warning to represent different likelihood of resulting in catastrophic fires, depending on whether it was a red flag warning condition or not. So that's the outcomes that we have. And then for each outcomes, there are 3 attributes that we quantify for each outcome consequences. And then there are trench dimension here that I will explain a little more detail in the next slide. But essentially what we do is that we have risk scores quantified for each combination of sub-driver, driver, outcome, and attribute, and trench and year. And that's what we use for risk reduction calculation as well. So if you go to the next slide. In a way, the bow tie presentation shows the arrows of left-hand side drivers leading into all the risk events, and then it goes out to the outcomes on the top graph. But under the hood in the model, there are in a way there are many bow ties, and each of the bow ties are one trench. So each trench has different values for these arrow frequency and consequence. So in a nutshell, current PG&E's wildfire risk bow tie that we use for the GRC in the middle of this year has 40 trenches, 37 drivers, sub-drivers, 10 outcomes, as you have seen in the previous slide, and then 3 consequence types: reliability, safety, and financial. So what that means is that we have 40 times 37 times 10 core lower values, and 40 times 10 times 3, which is 1200 distributions to compute the consequence of the risk event values, so core values. Next slide. So then now we have the risk event. If we are calculating the risk reduction, then we need to know how the program reduces the risk. So there are 3 types that we look at when we look at the program. So whether it reduces event frequency, or whether it reduces event consequence, or whether it reduces both of the bow tie, both sides of bow tie, whether it's frequency as well as the consequence. Depending on that, the calculation is a little different, or calculation is represented a little differently for risk reduction. So if the program reduces the risk by reducing event frequency, the first case, which is the most common, most programs are that type, the risk reduction calculation can be reduced to frequency reduction times the core. And then the second case, if it reduces the consequence, then the calculation can be written as frequency times the reduction in the core. And then in the third case, it's the sum of the 2 minus the delta multiplication on frequency and core side. So that's how we calculate the risk reduction if you represent in the formula. And if you go to the next slide, thank you. Given this formula, depending on whether the program is a mitigation program or control program, the calculation can be a little different. So here, let me describe a little more about what those mean and why we have a need to differentiate between the two. So when we quantify our risk in bow tie, our risk scores are using historical number of events or number of ignitions. So let's say we currently use 2015 to 2020 data. So it's 6 years of data, and we use that as our baseline risk. During those time period, we had control programs that were in place to help us to maintain that level of risk. And then from the current levels of the risk, current baseline risk, the mitigations programs are designed to further reduce the risk from the current baseline. So that's how we are separating the mitigation versus control. For the mitigation programs, it's designed to further reduce from the current baseline. And so the risk reduction or the frequency reduction is represented as a percentage reduction from the baseline. So the lower, delta lower or lower reduction is multiplication of the baseline lower, that was calculated in the baseline bow tie, and multiply by that effectiveness of mitigation in reducing the lower value. So that effectiveness percentage is an input to the model. So for example, if I give you an example on the left-hand side, so let's say the lower of a particular driver that this program addresses is 0.1, meaning that 1 in 10-year event for that particular mile for that particular driver or subdriver. And then let's say new equipment design mitigation that is expected to reduce the ignition or asset failure or ignition by 86% relative to the current conditions. Then the delta lower is calculated as 86% times 0.1 is 0.086 per mile. And then the frequency delta, or frequency reduction, is 100 miles. If you're applying to 100 miles of this mitigation, then 100 times 0.086, which gives us 8.6 in frequency reduction for that year. So that's the mitigation part. And then for the control programs, we are calculating a little differently currently. We have not done this way in previous WMP, which is 2021 WMP initiative RSE calculations, but we have done this for the current GRC in June. So for the control programs, it's sometimes easier to compute the number of frequency reduction that we expect to have directly. So instead of multiplying the baseline, we directly estimate how much we estimate this control program have been reducing or is going to reduce per unit of the work, and then apply how many work that we are going to do. So for example, let's say pole replacement program that we have been doing over years. Pole replacement program replaces 100 poles. That's a work unit in terms of the pole. And it's estimated to reduce, this is hypothetical, it is estimated to reduce the lower value by 0.02 per pole. So what that means is that if we replace one pole, then we are going to replace the pole that's about to fail. And so, and then for each failure of the pole, let's say there's 2% chance that could have resulted in as an ignition, then presumably we are avoiding 0.02 frequency or lower per pole. So the lower reduction per pole is 0.02. And then since we are replacing 100 poles, that's most likely to fail, then 100 times 0.02 is 2. So that's the frequency reduction that we calculate for the control programs. That's more easier to understand compared to trying to multiply to baseline risk score with the effectiveness. So next slide, please. So in the next 5 or 6 slides, we'll walk through the calculations. So the first step is to identify, when we have a program, which subdriver or driver and outcome relationships are targeted by a program. So taking a system hardening, overhead hardening as an example, we first identify which drivers are targeted by system hardening and is going to affect the lower value by implementing system hardening in the location. Next slide. Thank you. The second step is to apply effectiveness to calculate the delta lower. So here shows an example. It doesn't list all of the drivers that system hardening is effective. It's showing a subset of zooming in one driver called contact from object. There are 4 sub-drivers, as you have seen in previous slides: animal, balloon, vehicle, and other. And for each of them, we already identified the baseline lower value through the risk score calculation. The lower value here is given in the arrow, 4.6 times 10 to the negative minus 6. That means like per mile of this particular trench, we expect to have an ignition event with the likelihood of this much value. And we have that values for each of the sub-driver in here. And this is only for a particular outcome that's a high outcome, not red flag warning catastrophic fire outcome that's highlighted in here. So you can understand that there are these errors for the all other outcomes as well with the different probabilities. So for this particular outcome, the risk reduction per unit is a mile in this risk. So risk reduction per unit is calculated as lower reduction times core. Lower reduction for this particular driver is basically multiplication of the lower value times the effectiveness that's given in the arrow. So 4.6 times 58% times 10 to the minus 6 is the lower reduction that you can achieve for this animal sub-driver for resulting in non-red flag warning catastrophic fire outcome. You go through this calculation for all of the sub-drivers, multiply by baseline core value for that particular outcome, which will give us 0.28 per mile. And then we do this calculation, repeat for all of the outcomes that has different lower values for different sub-drivers. Well, if we sum them up, we'll have for per mile for this trench. So this is how we are doing. And let me explain a little bit more about why we are doing the calculation at this outcome level for each of the sub-driver. So what we have found is that the vegetation driver, for example, has more likelihood to result in a catastrophic fire. And that's really correlated with the wind conditions. And we represent that as red flag warning. So what that means is that vegetation driver, in this language, vegetation driver is more likely to result into red flag warning outcomes compared to non-red flag warning outcomes when we compare with the other drivers. So animal driver will have lower likelihood to result in red flag warning conditions compared to vegetation or equipment failure driver. So different sub-drivers will have different likelihood to result in different outcomes. So we do this calculation as a pair of sub-driver and outcome rather than aggregating all together into one outcome. So could you go to the next slide? So once we do this calculation for each year, we now calculate risk reduction for each year per unit of exposure. So now we need to have the third input assumptions, which is how much we plan to do. So this is taking an example of our GRC. So I can see there is a misspell in here, 2025 instead of 2026 in the third, in the fourth row of the left table. But what we need is a scope of the program. And so here we specify for this particular system hardening overhead program, each year we will do 423 miles and so on, 405 miles. And then we, in the nutshell, we are calculating risk reduction values for each year in the horizon and by each trench. And so risk reduction of this entire program for 2023 is calculated for 423 miles. And then 2024 programs 405 miles risk reduction is also calculated for each year in the future. So in here, what we are showing in the right bottom part is risk reduction per unit that was calculated in the method presented in the previous slide is multiplied by the scope. So in this example, 4 per mile is risk reduction per unit, and we multiply by 12.4 mile in the particular trench that we calculated that risk reduction for. Then it becomes 49.4 risk reduction in 2023 for that trench. And then we will aggregate we will aggregate risk reduction calculated for each trench over all trenches and combine that into one single number. Next slide, please. Thank you. So this slide shows how where the risk reduction is happening for a particular trench. So 2023 scope of work will have the benefit over 45 years. That's what we currently assume for the third parameter that we need, the life benefit life. So the blue bars on the bottom graph here is showing risk reduction that you get in each year from implementing, I think, what was it, 12.4 miles in 2023 for this trench for 45 years. And then orange is for the next year's work of additional miles. And I think that was 11.9 miles. And then the green cells are the work that is done in 2025. And then the last top bar is estimated work or forecast work that we plan to do in 2026 and go on. So these are the risk reduction that we need to estimate for the life of the risk reduction benefit, and these values are NPV'd into the present time. Next slide. So we have covered how the NPV of the risk reduction in the numerator of the RSE is calculated. And now this slide is talking about cost part, denominator part of the RSE calculation. This is a change from the last WMP or last ramp that we made in current GRC. We now try to account for all the costs associated with revenue requirement, even beyond what the capital cost is for capital programs, so that we can incorporate what the customers will need to pay eventually from a capital spending. That could be different from like expense spending. So in order to account for incremental costs for customers related to the capital spend, we calculated or we used Pbr Multiplier. For system hardening overhead, it's a distribution asset. And so for distribution asset, the Pbr multiplier is 1.389. And that is multiplied to the capital cost as a way to incorporate the present value revenue requirement. So in the right table, the miles are given, capital cost is in the middle, 1.5, almost 1.5 per mile, a million per mile. And then on the rightmost column, it is an outcome of multiplying 1.389, which is the Pbr multiplier, to the capital cost. And that is the unit cost in terms of the net present value that we use. Next slide, please. So in a summary, for the top graph, we show a particular trend that we calculate the risk reduction. So the middle chart is NPV of the cost, in which goes into denominator, and then on the right it shows the risk reduction graph that we basically sum them up by after applying the discount rate of 7% for each future years, and then discount back to the present time, and that's the NPV of the risk reduction. So we calculate the trench RSE as the ratio between the two, which gives us like 31. And our RSE is per $1 million. So this is 31 risk unit reduction per $1 million spend. And then the bottom part is showing once we go through the same calculation for other trenches as well, and then add them up for risk reduction and the cost. And so the total risk reduction is 16,844 divided by total cost, which is 2761, which gives us program RSE as a whole of 6.1. And you can see that the trench RSE, which has the highest risk reduction or highest risk to start with, has a higher RSE compared to the average program RSE. So that's the risk reduction walkthrough part. And then next slide is about RSE estimate and verification process that Devika Pent will go through. Thank you.
Thank you, Yumi. Can you hear me?
Yes, we can.
Thank you, Yumi. Perfect.
Yep.
So good morning, everyone. My name is Devika Pant, and I work in the Electric Operations Risk Management Group of PG&E. I'm going to start with talking about the RSE estimate verification process. Next slide, please. So I want to, in the first part, talk about confidence values and the range of uncertainty for RSE estimates. PG&E has not established numerical confidence intervals or values for its RSEs, mostly because of not having quantitative data for it for the most part. We show RSEs as a single number, and we do recognize that this approach can give the viewer an impression that a higher valued RSE is always better than a lower valued one. However, we do know that it is not always the case due to the uncertainty of the estimate itself, and as well as other factors that could be outside the control of the utility, such as weather and other natural forces. When looking at budget prioritization, we take into account not just RSE, but other factors such as the feasibility of execution, resource management, risk management, and strategic goals. One thing that I do want to highlight in this aspect is that in the recent risk OIR decision, the Commission adopted a transparency proposal that takes initial steps to identify and quantify sources of uncertainty. In addition to the RSE estimate verification process that I will be discussing in the next few slides, PG&E will continue to work with stakeholders to address uncertainty in the risk OIR proceedings. Next slide, please. So next, what I want to talk about is an overview of the RSE governance process. This is a very important part of something that we are doing for the Wildfire Mitigation Plan initiatives going into 2022. In October of this year, we formalized RSE governance process, and one of the highlights of that process is the creation of a RSE governance committee. That committee is currently working to evaluate initiatives that we are presenting in the 2022 WMP. Apart from, so what constitutes this committee is members from the electric operations risk team. We get insights from the enterprise risk team as well. And then most importantly, we have third-party technical advisors with a combined 30 years of operational engineering experience in gas and electric utilities who are part of this committee. So one of the important responsibilities of this committee is to ensure a replicable and documented RSE verification process for each initiative quantified. And just to revisit, in 2021, PG&E presented around 60 initiatives, and we are looking at each one of the initiatives through a rubric. And the next bullet point talks a little bit more about what that rubric is. We look at verification of RSE inputs in terms of activity, scope, exposure, and all of those things that go into calculating an RSE. All of that results in an assessment of confidence in RSE for each initiative into a low, medium, and high ranking. It is qualitative, however, there's rigor in the process. All of this results in, of course, an assessment at an initiative level for the confidence, but also recommendation how we can make it better next time around. Part of this process is also reviewing the approaches of other IOUs. So we can use that knowledge. And also, as we start to engage with IOUs in conversations about initiatives, that just facilitates a more robust benchmarking as well. Lastly, after we file the 2022 WMP, we will review the RSE governance process, see what works for us, what did not work, and that will result in future improvements. Next slide, please. So what are the systems we use to verify RSE estimates? So on the first column here, we see the systems that we use. And I'm going to talk a little bit about how we see the systems working best. So of course, our first system is subject matter expertise. Subject matter experts and their competence in the programs that they supervise is really the crux of what we get out of the system. We facilitate conversations with the SMEs. And usually what we do is we, if SMEs have a bunch of programs, we talk about relatively ranking the programs, thus sort of creating an intuition about how we are going to be using that knowledge into our models. So you usually start with that, and then we start then introducing programs that their programs may support, align to, enhance, or supersede, so as to then like build upon that and understand the relative positioning of the benefits of the programs. The second system we use is comparison against historical data. We assess metrics such as tag rate, creation, ignition rate, outage rate, and we see, and there's a look back factor here. And so we see that, well, this is what we thought the rate would change as, and have you really seen that post implementation? So we are starting to do more and more of that. The third system we use is third-party assessment. As I just mentioned, we started incorporating expertise from people who can give us an independent review and a consistent review of RC inputs. The fourth item here is cross-utility verification. And this is very helpful in alignment of logic so that we can truly see something that we may not have thought of and leverage how other utilities are thinking as well. Next slide, please. So with all of this, what are anticipated changes to RC verification process? As the first bullet shows, as always, we're always trying to incorporate more quantitative than qualitative components. Secondly, SMEs being such an important part of this process, we are continuing to educate our SMEs to facilitate a deeper understanding. And especially this time around, we're spending a lot of time educating them about the models and how their inputs impact the sensitivity or rather how their inputs are sensitive and how they impact RC calculations. We also expose SME to other comparable and related programs so that they have a good calibration of how the program fits compared to others, and thus removing some bias. The last two bullet points are really about expanding and capturing relevant data to support SMEs. In one case, so that we can have better RC inputs, we can have better effectivenesses, better benefit length inputs. And the last point is really about having data to inform a good look back of key RC related data points so we can have confidence in our inputs in the first place. Next slide, please. So here, I'm going to talk about our RC estimate and initiative selection process. Next slide, please. So here, the key message is that PG&E continues to evaluate how RC estimates can most effectively be used in its decision making. The first bullet here shows kind of a summary of how RCs are considered when selecting mitigation initiatives. RCs currently are mostly used at an overall program level to compare one program against another. However, as you see in the second sub-bullet, within system hardening, we are using RCs to get more nuanced and are using it at a project level. The RCs can be used to select different options such as line removal, overhead conductoring, and undergrounding. Of course, other decision-making factors are part of this process. Execution constraints, planning and execution lead times being some of them. And of course, we also take into account knowledge from the field and public safety specialists. In terms of anticipated changes, to see how we see this changing, PG&E will continue to learn lessons from its RC governance oversight process and plans to leverage those into the further application of RC in this space. Lastly, PG&E will continue to expand the development and reporting of risk reduction in RCs at a project level. That is certainly a desire. So with that, thank you for listening. That concludes PG&E's presentation.
Great. Thank you so much, Devika and Yumi. So again, we will reserve the questions to the Q&A sessions after lunch. Next, let's have representatives from SCE present on their slides. All right, SCE, the floor is yours. Thank you.
Sorry, give me a second here.
This is Chris.
Good morning, everyone.
Gary, sorry, can you hear me? Yes, I can hear you, Chris.
Okay.
Can
Sorry.
everyone
Sorry
hear
if I
me?
didn't
This is
prompt.
Gary. Doing
Yes,
an
we can
audio
hear you
check
both.
here. I think I heard a yes. Maybe we can do an audio check for Eric as well.
Argmon, can you hear me?
Yes, okay, great, thank you.
Okay, all right.
I think we're good. Okay, good morning, everyone. My name is Gary Chen, and I want to thank Energy Safety for facilitating this workshop. I will be kicking off the first part of the presentation, but I will be joined by my colleagues, Eric Wang and Chris Villas, who will be covering sections 2 and 3 of the presentation, as well as others on the risk and regulatory team who will be listening in and providing input as necessary. Could we please go to the next slide? Okay, then this section is entitled Risk Calculation Methodology. Next slide, please. Okay, great. So at its core, consistent with what PG&E has indicated, risk-spend efficiency is the ratio between benefits in the numerator and the cost in the denominator. But to really understand, the numerator, the risk reduction, we really need to explore the more foundational element of what is the risk currency. Essentially, how are we measuring risk? So the risk currency is constructed using the multi-attribute value framework. This is per the SMAP settlement to really define the weights, ranges, and scaling functions for the consequence attributes that we will be measuring. For purposes of the WMP and RAMP, we are focusing on safety, reliability, and financial. Safety is measured as an index unit, in this case, a function of fatalities and serious injuries, which you see on the screen. Reliability is measured in customer minutes of interruption, and financial is measured in dollars. For each of these attributes, we've assigned associated weights, ranges, and scaling functions. In the next slide, I'll discuss how the weights, ranges, and scaling functions work together, but I just want to leave that for here. So this MAVF was described and used in our 2021 WMP. And we know that our weight of 50% for safety meets the minimum threshold of at least 40% as set forth in the SMAP settlement process. Could we have the next slide, please? Great. So this is an illustrative example of a MARS calculation. For this example, I'm going to really focus on just one of the consequence attributes, in this case, financial. As you may recall on the previous slide, the financial range was from 0 to 5 billion. So that's what you see on the x-axis here. You see 0 to 5 billion. What you also see on the y-axis is a scaled risk score. So this is from 0 to 100 is a unitless risk score. And what you see on the blue line is a linear function that goes from 0, 0, the origin, to a point of 5, 100, right? 5 represents the maximum or the high end of the financial range, and it intersects at the 100 unit scaled score. So you see that, linear 45-degree line. That's the blue line. So imagine, how do we convert a natural unit, in financial consequences in billions to a scaled risk score? So let's walk through each of these steps. Step number 1, we identify the consequence value, right? Maybe from a simulation or from historical data, this particular asset would cause $2 billion in financial damage. So we locate where $2 billion is on the x-axis. We move upwards and see where it intersects the blue line, and then we go across to the y-axis and see where it intersects the y-axis. In this case, $2 billion, if you go up and then to the left, it intersects the scaled risk score, which is the y-axis, at 40 units of risk. As we've noted before, we also have to take into account the weight. Specifically, the weight for financial is 25%. So if we take 25% times 40, which is the scaled risk score, we get 10. So what we have done now is convert $2 billion in natural units, and we've now converted it into 10, what I call MARS units, multi-attribute risk score. Okay. So let's go on to the next slide, please. So I think what all the IOUs will indicate, there are a number of risk-spend efficiency parameters. I'll quickly go through each of these at a high level. The first one is exposure and scope. Scope represents how many widgets are you deploying, right? You may be deploying, for example, replacing 100 poles. But then you also need to know how many poles are in my system. Maybe there's 1,000 or 10,000 poles, right? So we need both the scope and really the population set for exposure. Mitigation effectiveness, Eric will talk a little bit more about this, but generally at a high level, mitigation effectiveness describes how effective a mitigation is reducing the probability or consequence of a risk event. From the probability side, we can think of it as an amalgamation of different sets of risk drivers. For example, animal contact, balloon contact, vegetation contact, transformer failures. Those are the different sets of risk drivers. For each mitigation program, it assigns a certain mitigation effectiveness to each of those specific risk drivers. A mitigation program can also mitigate the right-hand side of the bow tie, if you will. So these are the consequences of a risk event. The consequence of a risk event that we previously described were safety, reliability, and financial. For example, a mitigation program may mitigate 50% of safety, maybe 25% of reliability, and 10% financial, right? So a mitigation program can impact either the left side and or the right side of the bow tie. The third component of risk-spend efficiency is the useful life. For example, a capital-based program, maybe you're undergrounding a circuit, could give you 40 plus years of useful life. Maybe an O&M type program will, vegetation trimming. The vegetation will grow back the next year. So you have to go back the next year. So it's really 1 year of useful life. So that's how we account for the lifetime benefit stream of a particular mitigation program. And cost is, the mitigation program cost. So now that we've defined at a high level the parameters of how we calculate risk-spend efficiency, let's look at a summary of how we actually go about calculating risk reduction. Next slide, please. Okay. So in order to calculate risk reduction, we need to first assess what's the baseline risk. So as we previously indicated, probability is a function of the different sets of probabilities, right, for a particular asset. As I indicated before, it could be a probability of animal contact and probability of vegetation contact, and you have the consequences associated with that particular asset. In this case, we have probability times consequence equals the baseline risk. So just note that consequence is a function really of safety, reliability, and financial. So given that we've calculated a baseline risk, we now need to apply the mitigation program. As I indicated before, a mitigation program has mitigation effectiveness at the risk driver level or at the consequence level. So once we apply those mitigations, either your probability will decrease and or your consequence will decrease. In this illustrative example, for simplicity's sake, I've said that this mitigation program decreases the probability or likelihood of an event happening. By decreasing the probability and multiplying by the consequence, you get now the remaining risk, which is highlighted in the gray bar. And then you have your risk reduction, which is in the white. So now that we have the risk reduction, we multiply by the useful life and divide it by the cost to get a risk-spend efficiency ratio. So let me go on. So this is more of an illustrative high-level example. Let me now go on to an example that has numerical examples. Next slide, please. Okay, great. On this slide, this is a hypothetical illustrative example. Certainly, this is an extremely dangerous circular asset, but I'm just using round numbers just for ease of visibility and understanding. So let's go, from left to right. On the left-hand side, we have the probability of this event happening, right? So we have the different risk drivers. In this case, animal contact is 10% probability of ignition, balloon contact 10%, vegetation contact 20%, and wire-to-wire 10%. So in total, this particular asset has a 50% probability of ignition. Super high, but this is just for illustrative purposes. On the right-hand side, we have the consequences. Again, as we indicated, we're focusing on the safety, reliability, and financial consequences. For the safety and financial consequences, these are derived from our TechnoSilva simulation models. So what we do is take the population impacted from TechnoSilva and then convert that to a safety index score. For financial, we're taking the buildings and acres impacted and then converting that to a financial score. So in this case, we have 10, again, an illustrative example for safety index, and $2 billion for financial. For reliability, we're relying on 8 hours of interruption of per customer on this particular circuit. Again, illustrative examples. So consistent with what in a previous example in which we converted a natural unit into a Mars unit, right? So we converted 2 billion into 10 Mars unit. Again, 2 billion, if you go into the previous example, it converted to 40 units of the unitless risk score, and then we take 25%, so that equals to 10. So now we have 5 units of Mars score for safety, 5 units of Mars score for reliability, and 10 units of financial score for financial. We combine them together, so the total consequence score in the scaled unit risk score is 20. We then multiply the 50%, which is the probability of this asset failing, times 20 to get a baseline risk score of 10. I think we can go on to the next slide, please. Okay. So again, on the left-hand side, we're talking about the mitigation program now. So again, we have the probability of ignition on the left-hand side, which is 10, 10, 20, and 10, which is 50%. So let's look at this particular mitigation program. Let's look at its effectiveness. Again, as I indicated before, each mitigation program has an effectiveness for each either risk driver and or consequence. In this case, this mitigation program has 0 effectiveness for animal contact and 0 effectiveness for balloon contact, but it does have 25% effectiveness on vegetation and 50% effectiveness on the wire-to-wire contact. So then we calculate what's the remaining POI. For, again, step-by-step example, in this example, animal contact, since this mitigation program has 0 effectiveness towards animal contact, the remaining POI still remains 10%. Similar case for balloon contact. This mitigation program has 0 effectiveness, so the remaining POI remains at 10%. Let's go down to vegetation contact. This mitigation program is 25% effective, so the remaining POI is 15% effective, which means in essence, it's reduced, the risk reduction is 5%. So we do the similar calculation for wire-to-wire contact, in which it's effective at 50%. So now the remaining POI is 5%. We add up all the remaining POI, we're now at 40%. So what we started at 50%, and now because of the mitigation program, we're now at 40% POI. So let's go to step 3, which is the risk reduction. So we can then calculate what's the remaining risk, right? If you recall from the previous slide, 20 represents the consequence score, right? So 20, and we have 40%, which is the remaining POI. So 40% times 20 equals 8. We have 8 units of remaining risk. So what is the risk reduction? The risk reduction is simply the difference between the baseline risk, which we calculated on the previous slide as 10 units, and the difference, and then minus the remaining risk, which is 8. So now we have really, the risk reduction is 2 units. So to calculate the RSE in this simplified example, we have a 5-year benefit stream, right? So for year 0 to year 4, we have 2 units of benefit stream. And we take, let's just, just to keep math simple, the unit cost, the program cost us $1. So we take the NPV at 3%, which is the societal discount rate. And then we get RSE of 9.2. Okay, can we go on to the next slide, please? So we also want to talk about RSE calculation improvements. In general, all RSE components will continue to be refined over time. Eric will talk a little bit more about refining our mitigation effectiveness. Just more of to let the stakeholders know, or participants on this call know, that Decision 1812-014 really set forth the prescribed framework and methodology for calculation of RSEs, and also the MAVF that I previously described in this presentation. This ultimately feeds into our ramp, and then ultimately the utilities general rate case showing. The Commission has also opened a new proceeding, which is called a risk-based decision-making framework, or risk OIR, and it's really meant to address clarifications and or changes to the previous SMAP settlement and to really provide a roadmap in terms of phase 2 of the proceeding. Topics will include multi-attribute value framework development, risk tolerance that could lead to definitely changes in RSE calculations. And with that, I'm going to turn it over to my colleague Eric, who will describe a little bit more about the estimation process.
Thank you, Gary. Good morning, everyone. This is Eric Wong from SCE. I'm currently in the Wildfire Safety Group. Today, I'm going to talk about SCE's RSE estimate verification process. Let's go to the next page, please. All right, next page. All right, thank you. So in order to increase our fidelity and reduce uncertainty of the RSE calculation, there are several different things we're doing here today. So as the speaker pointed out from PG&E's slide in there, today we're quantify RSE with a point estimate. But that doesn't mean there's no uncertainty embedded in the whole calculation process. We understand that's in there, and we are trying our best to reduce the uncertainty throughout the whole calculation process. So one thing we do here is that we look into the whole elements, go into the whole calculation process. We would like to identify the one area that carries the most uncertainty, and that will become our focus. So with that in mind, let's look into all the different elements go to the whole RSE calculation. So as Gary pointed out earlier, that there are basically 4 different elements goes into the RSE calculation. The first one is scope and exposure and cost. So when you look at that part, this part is, we're tracking costs at a very granular level, at a unit cost level. And the scope and exposure is pretty much defined in there. And that means that there is really not much uncertainty carries in this estimate. So the next part is useful life. So the way useful life is being derived or calculated is either informed by manufacturer's claim, depreciation schedule, or estimate judgment. So this part, again, carries very, very high level of certainty in the actual data. So last part, let's look into mitigation effectiveness. So as Gary pointed out, this part is being applied to the original risk driver or consequence level, and then quantify how much we are reducing for that driver or for that consequences. So we use a lot of internal data if possible, and sometimes when the data is not in there internally, we will turn to external data sources if available, and benchmarking with some other utilities, or even use our estimate judgment. Can you imagine throughout this process, there are some programs we have been collecting data for many years. We're able to use data-driven approach more than the others. But there are some programs we don't have a lot of data yet, and we need to use some other data sources or rely on estimate judgment, and definitely that carries some uncertainty. So because of the nature of the estimated mitigation effectiveness, it definitely carries the biggest uncertainty throughout the whole calculation process. And again, in order to reduce the uncertainty to the RSE calculation, the mitigation effectiveness from this table clearly should be our focus. So let's go to the next page, please. So as I mentioned earlier, the mitigation effectiveness come from different data sources. It can be based on engineering science and benchmarking. And sometimes when we have historical data, we can use data-driven approach. And it can be coming from like testing, research, or estimate judgment. So SE has established a robust governance process to validate this whole process, making sure that the data is validated and benchmarked, reviewed, and challenged. So in general, we have an annual process to develop, review, and update the whole mitigation effective values. And as starting point, we always look into subject matter experts based on their data, if it is available, and provide the initial input. That includes documentation, in particular, the documentation of data sources, assumptions that we made, the calculations. And in the end, we'll be using a lot of historical data and benchmarking test data as well. So after that initial step, we'll be meeting with management to review the estimate, and then in particular, look deep into the supporting document, making sure that everything is correctly provided and also everything makes logical sense. Of course, the last step here we're taking is to bring all the information to challenge sessions, where we'll be looking into every single activity, look into all the documentation, and verify or validate the input, assumptions, and the final results. So one thing I want to point out here is that when we go through those challenge sessions, we don't typically look into one program at a time. We want to make sure that the program, when compared to other programs, still makes sense in terms of the mitigation effective values. For example, when you look into the data from program A, it may show certain numbers in there. And when compared to program B, maybe it needs some calibration. So those are all the process we going through all the different governance process, making sure that we have the best estimate on mitigation effective values, and to make sure that we reduce uncertainty in the whole RSE calculation process. So let's go to the next page, please. So in addition to the robust governance process of the whole RSE calculation process, there are also many other initiatives or improvements that we're making today to make sure that we get to a point where we feel we are very confident with the mitigation effective values. So one of the improvements we're making today is to working with some other LUs to look into their numbers and benchmarking. If they have already produced a lot of data, maybe we can use them directly. So one example is that we're now having a joint LU co-conductor mitigation effective values workshops. And throughout those workshops, we will be looking into the data and benchmarking with each other. And also we are taking the information from lab testing into the whole calculation process. So the next part is that, if you recall, there are some activities we're not able to quantify Rscs from last year's flooding due to a lack of mitigation effective values. Now we are taking additional effort to look into the mitigation effective, estimate those numbers and trying to quantify additional Rscs. So, and also as I pointed out earlier that when we have collected a lot of data, we're expecting to use that data to refine the mitigation effective values to inform the whole RSE calculation process. So ultimately, we would like to come to a point where we'll be used data-driven mitigation effective values at sub-driver level if the data is available to us. So with that, I'm going to pass on to Chris, who's going to walk us through SC's initiative selection process.
Thank you, Eric. Just a quick double check on audio. Can I be heard okay here?
Yes.
Okay, great. Thanks, and good morning, everyone. Chris Vias, I'm the Principal Manager for Regulatory Risk in the Enterprise Risk Management Organization in SCE. I want to thank OEIS for coordinating the workshop today. I know it's a lot of work and we very much appreciate it. So Gary and Eric have talked through the details of how we analyze and validate on these calculations. I'm going to talk a little bit now about how RSEs fit into the broader initiative selection process. And can we have the next slide, please? And the response I'm going to give today takes in some measure its basis from the WMP revision process for the 2021 WMP annual updates. And in particular, on critical issue SCE02, SCE, in response to that, actually provided a very detailed narrative explanation and graphical representations of its general process for selecting wildfire and PSPS mitigations. And in the final action statement, OEIS found that our response on this critical issue had adequately addressed all parts of this critical issue, and that our work product brought clarity to the decision-making process by illustrating what factors such as risk reduced and RSE are weighted more heavily than certain other factors. We will continue to utilize RSEs and refine our use, calculation, and understanding of them on a going forward basis. Now, to turn to the decision-making process itself for wildfire and PSPS, can we please go to the next slide? I know this chart is hard to read. It is found in an easier to read fashion in our actual response on critical issue SCE02, and SCE does respectfully direct parties to that if they want more information or an easier to see version of this, and we'd be happy to provide the link to that if any party needs that, if any person needs that. But when we look at this, let's just talk about it in broad strokes of a four-step process. And I'm going to go very briefly over certain of the initial parts to really focus on the RSE part of it. So broadly speaking, the process can be broken down into four major stages as outlined in this flow chart. First, SCE evaluates or reassesses and then prioritizes wildfire and PSPS risks. This involves determining the drivers and subdrivers and consequences of wildfire risk, quantifying those drivers, subdrivers, and consequences as appropriate, and then modeling it across SCE's high fire risk areas. The second major step is then we identify the choice of mitigations to address the risk. In other words, we pinpoint the various mitigation alternatives. And here we focus on potential options to reduce the risks that we evaluated or reassessed and then prioritized in the first step. And these potential mitigation options come in the form of existing mitigations, modified mitigations, or new mitigation initiatives. I'd also like to point out when we're examining new mitigations, technological maturity is an important factor. There's sort of a division between new mitigations that are commercially ready to deploy to reduce risk and new mitigations that need to be piloted and further evaluated for potential future deployment. For mitigations that are commercially ready for deployment, we identify those new options through, among other actions, by benchmarking with other utilities, studying and adopting emergent best practices, looking to guidance from engineering and technical industry committees, et cetera. And in some cases, though, when we have a technology that is not quite ready for commercial deployment, then that's piloted and further evaluated for potential future deployment. And typically that SCE will engage in further consideration through a pilot project, demonstration effort, or smaller scale field testing or pilot deployments. We want to make sure something is fully studied or evaluated to a reasonable degree through such reliable sources before deployment. The third step, and now we will be getting to RSEs, in the third step in this general decision-making process, we then evaluate the mitigations and select the appropriate ones from amongst the alternatives using decision-making factors. This usually starts with an estimation of how effective each option can be in reducing the various wildfire and/or PSPS risk drivers and consequences. And here we're focusing on efficiently reducing the risks as quickly as reasonably possible, prioritizing mitigations to the areas of our system that present on a relative basis the highest risk, and doing so in a manner that appropriately minimizes customer costs and service impacts. So therefore, our selection of wildfire initiatives or PSP initiatives has to consider several factors in the decision-making process. And those key factors include, as one of the prominent ones, RSE scoring. Other factors include, as I touched on above, earlier rather, cost and affordability. Also, resource constraints are important, technology availability, and the risk profile for high fire risk areas in our service territory, and the risk profile of assets, as has been touched on earlier. So RSE is a key factor here in this third step. And if we can go to the next slide, please. And this shows how this graphic illustrates how RSEs fit into as one of the factors in trying to decide whether something is, whether it favors selecting the initiative or not favoring selecting the initiative, discouraging selection of the initiative. And so what do RSEs specifically do here? Well, they help us evaluate the relative cost effectiveness of potential initiatives. And this in turn provides insight concerning prudently allocating our resources, our funding, and our efforts to efficiently mitigate wildfire risk. That being said, it's not in the best interest of our customers or the communities we serve if we were to carry out any kind of, for example, comprehensive wildfire risk mitigation plan if we were solely basing it on RSEs, because an RSE necessarily cannot take into account certain operational realities like resource constraints or service disruptions. An initiative with a relatively higher RSE is generally favorable compared to one with a relatively lower RSE. But when an initiative has a relatively lower RSE, it could still be selected. Let's say, for example, if it's easier to deploy quickly in order to mitigate risk, or if it addresses a particular risk driver that other mitigations do not, or if, for example, it reduces overall risk on a greater basis, even if it costs a little bit more. So RSEs are very important here, and they are a part of the decision-making process in this step 3 as one of the key factors. The fourth step is that we prudently scope and deploy the chosen mitigations. And as part of the ongoing risk management process, the factors, including RSEs, help management assess the technical, the operational, the resource, the financial, and the regulatory considerations of the risk mitigation initiative. And so it helps in helping make sure that we are properly assessing, examining our overall mitigation plan, and the RSE scores thus are used in the fourth step as well as the third step in helping us here in the fourth step evaluate and further validate or focus our decisions on mitigation selection when mitigations are evaluated in the aggregate and as an ongoing item, because we continue to monitor deployments in light of relevant conditions or circumstances. And we're always striving to improve through lessons learned, through metrics information, and feedback from our customers, our regulators, and other stakeholders. And that concludes my presentation of this area.
All right. Thank you, Chris, Gary, and Eric for presenting for SCE. We are a little bit ahead of schedule, but that's okay. So we are ahead by about 30 minutes. And what we'll do is we'll still keep the cadence of taking a break now and then following up with SDG&E's presentation, and then we'll have lunch afterwards. With the extra 30 minutes, what we'll do is we'll split that 30 minutes into 2 extra 15-minute blocks for the utility Q&A session and the panelist Q&A session. So so we'll have a little bit more time for the after lunch Q&A session. So at this point here, let's take a break, and then we'll all come back at 11 a.m. So yeah, walk around, get some water, and SDG&E will be up next. Thank you so much. All right. My clock here reads 11 o'clock. Let's give one more minute for folks to get back to their chairs. So next up, we have SDG&E presenting. And because we're a little bit ahead of schedule, like I said, we will be giving a little bit of extra time for the 2 Q&A sessions this afternoon. So the current schedule here is going to be lunch from 1 to 2. And then afterwards, we'll have the first utility Q&A session. That's going to be from 1 to 2:45. And then we'll have a brief break. And then we'll have the panelists Q&A. And then we'll have closing remarks. And James, could you bring up SDG&E's presentation, please? Thank you. All right, SDG&E, floor is yours.
All right, before I get started, Alan, can you hear me okay?
Yep.
Awesome, thank you. Hello, everyone. My name's Nisha Menon. I'm a PM in the Wildfire Mitigation Strategy team at San Diego Gas and Electric. I'm here with my colleague, Jillian Simmer, to present the RSE methodology, the RSE initiative selection process, and kind of give you an overview of everything. So with that, next slide. Next slide, please.
Did you not see this slide change?
Is it on what is risk spend efficiency?
It's on the agenda. I'm sorry.
Okay, no, it's all right.
Do you want me to go to the slide after the agenda slide?
Yes, please.
Okay.
Thank you. All right, so what is risk spend efficiency? So the RSE is a calculation of the effectiveness of a mitigation. It really is a way that helps us understand the risks and better compare mitigations when we're addressing risks. So the simple equation for RSE is risk reduction times the lifetime of benefit divided by the cost. So we'll dive into the details of each component of the calculation in the upcoming slides. Next slide, please. So the RSE calculation methodology overview. So the intent of this slide is really to show a simplified step-by-step process to calculate the RSE. So the first step would be to calculate the baseline risk score calculation, followed by what is the risk reduction component. Once we've determined that, we'll kind of dive into what's the net present value or the lifetime of benefit risk reduction. Then we'll look into the total cost calculation, and that will lead into the actual value of RSE. The table at the bottom, at a high level, this table just shows, it's an illustrative way to see what are the 2 RSEs for 2 different mitigations. In this one, we're looking at underground and covered conductor and how the RSEs are for different segments on a circuit. Again, this is just an illustrative view, and we'll kind of, again, dive into the details in the next few slides. Next slide, please. All right, so the way we've structured the next few slides as we walk through a RSE calculation is the top portion of the slide is kind of the general equation or calculation. And then the bottom portion of the slide is really focusing on one example, kind of like a walkthrough. So in this slide, we have segment A as an example with the wildfire risk. So the foundation of RSE really is to calculate the risk score. And a risk score is really the likelihood of a risk event times the consequent of a risk event. So in this example, as I mentioned, for segment A, we're looking at what is the likelihood, which is based on the historical ignition data. There can be SME input in there or judgment, and that's kind of used as a starting point to come up with the likelihood. The consequence of a risk event uses the MAVF, which is a framework that really takes all the potential consequences. So what are the consequences if this risk was to happen? And it comes up with a value. And that's really based on 4 components, which is safety, financial, reliability, and stakeholder satisfaction. The consequence that we're looking at from a wildfire risk standpoint is from our SDG&E's wildfire behavior modeling. So in the example here, you can see that we have taken the likelihood of a risk event, which is 2.71. We've kind of taken the core, which is the consequence value, and we multiplied the 2 to kind of get the wildfire risk for segment A as 0.43. And again, these are illustrative examples just to kind of walk you through it. So with that, we'll go to the next slide, please. All right, so now that we have that baseline risk, we are going to go and determine what is the risk score reduction value. So risk reduction determination, is based on historical data. It can be SME driven, and it really is on this calculation that's shown above. So really that is the pre-mitigation times the likelihood of pre-mitigation times the consequence of pre-mitigation minus the post-mitigation likelihood times the post-mitigation consequence. So if we were to look at the example that we were talking about, for segment A, we take the likelihood pre-mitigation, which is 2.71. And for this segment, we're going to apply an mitigation of covered conductor as an example. And we take the post-mitigation 0.948, and you multiply that by the consequence to come up with the risk reduction. As mentioned by the other IOUs, there are occasions where the mitigation may only apply on one side of the equation. So in this case, it's only applying on the likelihood side, so the consequence will stay constant. Next slide, please. All right, so the intent of the next 2 slides that I'm going to show is how do we come up with that post-mitigation likelihood. So we utilize efficacy studies, ignition counts, SME input to produce the ignition rate reduction for each mitigation. We then apply that by the pre-mitigation lower or the likelihood value to come up for the ignition rate reduction that's associated to the mitigation. So there's 2 examples that I'm going to share on this slide. I'm going to focus on the chart on the left side, which is the traditional hardening efficacy studies. So in this example, we're looking at the efficacy study for traditional hardening. So at a high level, right, there are a number of faults for pre-traditional hardening, and then there's a number of faults post-traditional hardening. So the reduction, there's based on these numbers, there's a risk reduction of 44.5% of faults. And this is the number that kind of feeds into that risk reduction. The table on the right side, that's more SME driven. And this kind of ties back to that example we're kind of following for segment A. So we're applying the mitigation of covered conductor. So since we don't have enough data around covered conductor, as we're still learning, it's kind of a starting point. There's a joint IOU working group that's also working on the, and is looking at the covered conductor effectiveness. So that might affect the assumption in the future. But for now, in this example, we're looking at the covered conductor effectiveness that shows the estimates of effectiveness for different ignition sources. We also started using traditional hardening kind of as a starting reference point. And we went through a very thorough exercise with SMEs where we kind of estimated this reduction for every ignition source. Based on that, we came up with the risk reduction of 65%. So just wanted to kind of share there's 2 different approaches when we're kind of coming up with this risk reduction. The left side again was more efficacy studies driven, and then the right side is more SME driven. Next slide, please. So this slide really focuses on, so how do we kind of come up with that post-mitigation likelihood, which we kind of talked about, 2 slides before this. So if we were looking at the traditional hardening efficacy study, we kind of take the pre-mitigation likelihood and you multiply that by that ignition rate. So when we said 44.5%, and that's how you come up with the 1.504. And then the bottom of the bottom half of the screen is coming up with the likelihood for the covered conductor calculation. So again, tying it back to our example, right? Based on that similar methodology of traditional hardening, we take the pre-mitigation likelihood of 2.71 and we multiply that by that subjective covered conductor ignition rate. And that's how we come up with that post-mitigation likelihood of 0.948. Next slide, please. This slide focuses on the net present value reduction, looking 40 years into the future. So the risk reduction is 3% that is depreciated year to year. So in this example, what we're doing is we are assuming that covered conductor has an estimated age of 40 years of benefit. So we take that lifetime of benefit factor and we multiply that by the risk reduction that we just calculated in the previous slide to kind of get the net present value. So this is what the future benefit of this long-term activity will be. And that's how we come up with the 6.52. Next slide, please. The next component of the RSE calculation is the total cost determination. So really, the total cost determination is the direct cost of the mitigation effort. And in our example, for segment A, we take the 0.46 number of miles times the cost per mile for covered conductor. And that's how we kind of come up with the $690,000. So really the equation is basically number of units times the cost per unit. And that's how we come up with the total cost determination. Next slide, please. So really to summarize all the components of the RSE equation and keeping it simple, what we did is we kind of put this table together where we said, here's the RSE for the 3 different mitigations for segment A. We kind of walked through with numbers for covered conductor. So we also just added 2 other mitigations such as traditional hardening and hotline clamps, just to kind of give you an illustrative view on how we come up and with 3 different values for segment A, and then how do we compare them and use them. Next slide, please. So RSEs are a good data point for utilities to consider, but it can't be the only deciding factor for mitigation selection, as there's a lot of assumptions that go into the calculation. There's a lot of uncertainty in general around risk assessment, as it doesn't really account for everything or all the variables. And there's definitely room for that SME input or judgment or just adding that human factor to it. So based on that, here are some overarching assumptions that go into the risk calculations. And assumptions actually can vary from mitigation to mitigation. So taking into account the covered conductor example that we've been walking through, here are some assumptions for that. So the first one would be the cost per unit. That can be really based on, cost per unit can be based on information from SMEs, from our planning team, and those are like estimates at this point. The mitigation effectiveness, like I said, there's some element of the SME input where we say a mitigation is X% effective. Lifetime of benefit, here we're saying 40 years for covered conductor, 25 years for hotline clamp. So there's some assumptions kind of built around that as well. And this isn't a complete list, but this is just a list of few to kind of give you a general sense. Next slide, please. So what are the anticipated changes to RSE calculation methodology from now to 2023 WMP? The SDG&E is continuing to update and improve risk assessment. It just depends on what kind of change we see in data sets and assumptions. Also, as more data becomes available, if there's any change in logic or if we learn of a new different technique, we'll definitely apply that. If there's updated risk models, as technology is continuously improving, and as we plan to gather better unit cost estimation. We also plan to incorporate life cycle cost. And then last but not the least, we're continuing to evaluate the overall framework from stakeholders and other proceedings. Next slide, please. So the RSE estimate verification process. So before we kind of go into that, we wanted to say that SDG&E is not currently using confidence intervals and range of uncertainty in its risk assessments today. However, we are continuing to consider this, and we're planning to improve as we gather more data. Regarding the estimate verification process, our enterprise risk management department, they are the ones who develop the RSEs and kind of go into the details and do all the number crunching. Then we also have subject matter experts, and they play a key role in the verification process as they're validating the data, making sure it's passing their gut check, especially in areas where we may be lacking some data. Additionally, we also do reviews with other team and management. So internally, there's a pretty comprehensive way of how everyone takes a good look at the RSEs. Additionally, we also have external vendors. We've actually recently engaged them where they're starting to assess and review our RAMP RSEs. And they're also identifying areas of improvement. And they're helping us kind of validate the estimates that we're going to be coming up for our 2022 WMP. Well, with that, I am going to pass it to Jillian, and she'll kind of walk through the next section.
Hi, everyone. Can you hear me? We'll look for a thumbs up, maybe.
Yes, we can.
Okay, thank you. Hi, I'm Jillian Semmer. I'm a project manager in the Wildfire Mitigation Risk Strategy Group at SDG&E, and I'm going to talk about how we use RSE estimates in our initiative selection process. I'm going to start first here with an overview of our approach to risk-based decision making. First, we are evaluating baseline risk. This is using the risk quantification framework, using our MAVF, doing a lot of the calculations that Nisha just took us through as far as lore and core of PSPS and wildfire risks through the aspect of safety, reliability, financial, and stakeholder satisfaction attributes. From there, we develop a comprehensive catalog of mitigations. This could be compliance-driven mitigations such as inspection requirements for assets or vegetation. This includes new technology, for example, drone inspections. We've also developed mitigation initiatives through analyzing equipment failures. For example, high conductor risk associated with small copper wire. That led us to developing our firm and prime programs, where we replace small copper wire with hardened wire, or we do wood to steel pole changeout. So we're continuously looking at qualitative and quantitative metrics for our mitigation initiatives, seeing if we can support new ones or continuously enhancing existing ones. From there, we're evaluating the mitigation initiatives, and one method is calculating RSEs, which I'll discuss more how we apply it. Other methods for evaluation include third-party studies and benchmarking with other IOUs. And then from there, we use refined methodologies like risk modeling and working with subject matter experts to prioritize work based on more granular data. So this essentially shows that, as I'll discuss in the next slide, while we use RSEs differently across mitigation programs, all of this is based in risk analysis and risk-based approach to decision making. Next slide, please. Okay. So getting to the meat of how we used RSEs in initiative selection, I focused on 3 broader areas of our wildfire mitigation programs. The first 2, asset management and vegetation management. You can see that their compliance requirements and SDG&E standards drive a lot of the scoping. There's a lot of cyclical programs and initiatives involved, such as annual tree pre-inspections or 5-year corrective maintenance programs for certain assets. So a lot of the scope is driven by compliance requirements and standards. And then from the outcome of those inspections, we'll identify repairs needed, for assets, or if a tree needs to be pruned or removed. And those repairs are prioritized by condition and compliance timelines. However, even for these initiatives, RSEs are still calculated. They're utilized more after the scope is completed, when we have the more data on the total costs, and used more as data points for comparison with other initiatives in our program. On the other side, with grid hardening, for our large capital programs, especially those like strategic undergrounding, like covered conductor, we're looking at high cost projects that are typically associated with high risk reduction potential. So we utilize more modeling and analysis on these high capital programs. So we've developed our wildfire next generation system, our WINGS model, that I'll describe more in detail in the next slide. But this model gives us risk rank at a segment level, so we can see the highest wildfire risk rank segments. It gives us segment level RSEs using the different mitigations, so we can do some comparison, as well as giving us a portfolio view. So in grid hardening, again, this high expense capital programs, we're utilizing RSEs more in the scope information side. So at this time, SDG&E is utilizing WINGS to inform grid hardening scope beginning in 2023 because of the approximately 18-month duration for scoping. But we're already seeing that there's potential opportunity, for example, of evaluating segments where we have planned traditional hardening, or that's already in flight for 2022. And now we're looking back and seeing if our risk models support potential pivot to covered conductor for more risk reduction at a lower cost. So again, most of this is coming in 2023, where we use RSEs in scoping for grid hardening, but we're looking and evaluating how we can use that sooner as well. And so going into the next slide, please. RSEs are a factor for the grid hardening initiatives, but they're not the only factor too. And now it's worth looking a little bit deeper into the WINGS model, because that is what's informing our grid hardening scope, where we are utilizing RSEs for 2023 and beyond. So here we're taking a look at inputs for both wildfire and PSPS, attributes like weather, like historic ignitions, vegetation, circuit factors. We're looking at conductor age. We have worm conditional impact values from Technosilva studies. And then on the PSPS side, we're looking at breakdown of customers and weather data as well. And then in the WINGS model, we also have information like mitigation unit costs and mitigation efficacy. And from some linear and conditional functions within the model and using our MAVF framework that we previously discussed, the outputs of the WINGS model include segment risk ranking, like I mentioned, segment RSE analysis, so we can see what covered conductor or undergrounding or traditional hardening on different segments, what kind of RSE values you get. And then we get a portfolio or an analysis of multiple different portfolios. So I want to delve deeper for a second into this portfolio analysis. This is just illustrative, but out of WINGS, for example, the P3 portfolio 3, that is the light blue line that shows us when we're looking at total cost versus total risk reduction. That is the highest overall risk reduction for the portfolio of a mix of mitigations, but it comes at the highest cost as well. And you could compare that to portfolio 5, for example, that might be a more optimized mix of undergrounding and covered conductor. You get slightly less risk reduction than portfolio 3, but at a much lower cost. So these are what we're analyzing as far as outputs from the WINGS model. If you can go to the next slide, please. So from WINGS, we're looking, our objective was maximizing wildfire risk reduction while selecting the most cost-effective mitigations. And this involves looking at risk across over 600 segments in the HFTD, comparing those RSE alternatives and looking at the portfolio analysis. And what we initially selected targets an approximately 83% wildfire risk reduction. But this portfolio gets evaluated because there's not a single driver to the risk reduction. And it's really a balance of risk reduction and costs. So for example, if we see unit costs of undergrounding going down, or alternatively, if you see the effectiveness of, say, covered conductor going up, the optimized portfolio will give a different mix of recommended underground and covered conductor on a segment basis. In addition to WINGS, we're also evaluating PSPS reduction for programs like generators, microgrids, and even undergrounding, and looking at customer impacts. So this is not a hard science, it's an art and a science mixed here, and involves continuously updating, evaluating assumptions that feed into those RSEs and how to best utilize those RSEs to create a portfolio of mitigations. Next slide, please. So RSEs are not the only criteria for determining what mitigation we select. As I've mentioned previously, for example, around asset management and vegetation management, there's a lot of compliance requirements and standards that affect what mitigation is happening at what time. But these other factors on the right, scoping, engineering and design, and construction factors do play a role, particularly associated with grid hardening initiatives. So the outcome on a segment basis, say for segment A from WINGS, was doing covered conductor or doing undergrounding. We still have to see if that is feasible from a field perspective, from a constructability perspective, from a reliability and circuit connectivity perspective. So there's still more involved. The process for confirming that or reviewing it includes is initial desktop feasibility study. That's where we're looking at constraints associated with permitting, with geography. We may be going up a mountain and it doesn't make sense to go from overhead to underground, even though that's maybe the highest RSE. There could be existing infrastructure that maybe in a different area makes sense to tie into an already existing undergrounding project for less cost. So we're utilizing this desktop feasibility and stakeholder and subject matter expert input at this stage. Then there's still other engineering design factors that we don't have an answer to just from a desktop review. That includes looking at survey results, talking with other agencies and communications infrastructure providers, for example, and coordination. And then finally, construction factors. So ultimately, the availability of labor and raw materials impacts what mitigation can be actually selected, as well as the ability to work through the aforementioned constraints, whether it's land, permitting, cultural, and then looking at, again, at the impact on customers, on the impact on the system as a whole. So RSEs are good data, important data, particularly useful in scoping and grid hardening, but there's still other factors of consideration. Next slide, please. Okay, as far as anticipated changes to how we use RSEs in mitigation selection going into 2023 WMP, a priority of ours is continuing to improve the accuracy of RSEs. This is associated with our improving and enhancing our WINGS model. It's associated with continuing doing studies, joint IOU studies, getting more actuals and cost information from programs that are newer, looking at life cycle costs and benefits of avoided costs. So that's continuously improving the accuracy of our RSEs that we're using. Additionally, we're developing an enterprise-wide level capital allocation and planning tool. This is going to utilize approaches that cover not just mitigations within the HFTD, but across the company. And so I think more data points will support potential different approaches to initiative selection. And ultimately, what we're doing here is through both this workshop and internally is learning and figuring out if there's and exploring other opportunities to apply RSEs. We are further along by the nature of grid hardening projects in how we use that for scoping, and we're going to continue to look at whether we can apply similar approaches to some of our other initiatives outside of grid hardening. And I think that's our last slide for this. Our final one was really that fourth point of that we'll be including our summary RSE spreadsheet as part of the upcoming report. That's it. Thank you.
Great, thank you so much. So next here, we did finish a little bit early again, but that's okay. That means we have a little bit of a longer lunch. So let's take lunch now. So we will be back at 1 p.m. and then we're going to start the utility Q&A. So members of the attendees, if you have questions, please utilize the Q&A feature. And just make sure that we're addressing who the questions are for. And then after the utility Q&A session, we'll take a short break and then we'll have the panelists Q&A where we'll discuss some questions and topics relating to RSE calculations and utilization. And then we'll have some closing remarks. So I hope everyone has a good lunch and we'll be back here at 1 p.m. Thank you.
initially were for 2023 at least. Make sure we have sufficient staffing.
Somebody keeps unmuting themselves just to give you a heads up. Might want to be a little more careful. Gary?
Hi, folks. Quick announcement. Earlier just now, we had to remove Gary Chen from SCE from the panelists list because we were getting some music coming from his end. If folks from the SCE team could send me another email address for Gary, then we'll be able to send him a different invite link to join. Seemed like we're having some connectivity issues where there was an audio lag. So yeah, please send me an email with Gary's info. It has to be a different one that was sent earlier today for the invite link to work. And I'll make this announcement one more time when we get back from lunch in case if people are still away. All right, everyone. It is reading 1 o'clock on my computer here, and let's get started with the utility presentation Q&A session. Just want to maybe give another minute or so for everyone to come back from lunch. And I'll make the announcement again. During our lunch break, we had a little bit of a technical difficulty with the hold music coming through. We had some audio coming from Gary Chen from SCE, and we just wanted to ask the folks from SCE to please send an alternative email address for Gary.
Gary,
Oh, yes.
Gary is currently connected right now.
Oh,
So-
he's already back.
Yeah, it shows that he's here.
Oh, okay. I know from SCE, we have Gary Chen with the CHENG and then also CHEN. Want to make sure that we have all the necessary people from SCE.
Hi, this is Chris Bias with SCE Audio Check. Can you hear me?
Yes, I can.
Great, thank you.
Alan, can I get some clarification on how you want to handle the Q&A? Would you like me to bring the presentation down so everybody's on screen for the Q&A, or do we want to keep the presentation up during the whole time?
We can bring the presentation down so we can see the faces of the speakers. And James, we might have to ask you to refer to the presentation slides if a question requires some visual aids.
Of course.
Thank you. Yeah, so as we move into the Q&A session here, what I would like to do is utilize the hand raise function. So if anyone from the panelists have questions for the utilities from the presentations this morning, please raise your hand. And then what we'll try to do here is allow the panelists to ask the question in the order that they have their hand raised. And perfect. So
Alan, you mean attendees, correct? Also?
And also attendees, yes. And attendees are also welcome to use the Q&A chat as well.
And just to remind the attendees that are dialed in to raise your hand on, if you've dialed in on the phone, press #2 to raise your hand and you'll be put in the queue to be unmuted.
Great, thank you so much, James. And with that, we'll ask all speakers while they're asking their question to give a short introduction of who they are and what organization they represent before asking the question. And we only have to do that, during the first time we ask the question. So I see here that Wendy, you have hand raised. Go ahead and unmute.
Alan, this is Jessica.
Yes.
I was just going to ask, before we move to folks with their hand raised, I just wanted to let you know that we did receive 2 questions in the Q&A from earlier this morning. So I don't know if you want me to read those first.
Oh, yes. Sorry, I missed those. So yes, Jessica, go ahead.
No problem. So we just received 2, both from Marty Kurtovich. The first one asks, is PG&E's user guide available to all parties? And then I'm not sure who would be best to answer that question, but then the second question is also for PG&E, asking if PG&E is including undergrounding in its evaluations.
Yeah, so for the first question, the user guide, Marty, correct me if I'm wrong, but I believe you're referring to the PG&E Enterprise Risk Model Documentation and User Guide. That was in the footnotes where we can find more information about the present value of revenue requirements. Would someone from PG&E please speak up about where users can find that documentation? Earlier we had Yumi and Devika present from PG&E. Do we have an answer to where folks can find that and if it's available to the public?
Hello, this is Devika. Can you hear me?
Yes, we can.
Okay, perfect. The user guide, I believe, is part of the filing that we did in the GRC process. We can get it to you as part of the December 17th filing. I don't have that with me right now. I know that enterprise risk does, so we should be able to get that to you. Also, I see another question about undergrounding. I have reached out to the PMO right now to see where we finally landed on that. I know that there were a lot of conversations about the exact scope to be included in the Wildfire Mitigation Plan 2022, and I hope to get that response sometime soon, hopefully during the Q&A.
Okay, thank you.
You're welcome.
And a quick point to follow up on to what Devika said earlier about the December 17th report. So along with this workshop, there is a separate requirement for the utilities to submit some additional information, including a comprehensive spreadsheet that includes some of the costs, the risk reduction scores, and that is going to be submitted to the RSE group docket, and that will be distributed to everyone that's part of the service list. Thank you. And before we get to Chris Park's Q&A question here, Wendy, go ahead and ask your question.
Okay, thank you. I have two questions. One is, I wonder if, it looks to me like one of the biggest differences between the RSE calculations is that PG&E includes a factor of 1,000. And I think the other two utilities did not do that. I mean, so I'm just wondering, in a real simplistic thinking, if we took that factor of 1,000 out, would the RSEs be more comparable across the utilities, or am I missing something? So I'm kind of looking for some explanation on that.
Just a reminder, as panelists, you should be able to unmute yourself freely and speak amongst yourselves about whatever's happening. So,
okay, hi, this is Fred Haynes from the RSE section at the CPUC. I'd perhaps like to piggyback on Wendy's question by asking it a little bit differently. We did see in PG&E's presentation a scalar value of 1,000 applied to making the risk value calculations. Are there comparable values used by Southern Cal Edison and San Diego Gas and Electric? And what are those values that they use? So I'll ask the question first to Southern Cal Edison. Do you use a scalar value for readability, which is, I think, the reason that PG&E uses their scalar value?
So this is Gary from Southern California Edison. So what I think I saw from PG&E was a scalar on the consequence of risk event, the core. Is that correct?
Well, let's check their presentation.
if you want me to move back to a slide, I can move back to a slide also.
Yeah,
whatever
James,
presentation.
Could you go to slide number 7 on PG&E's presentation?
Yeah, give me a second to bring it back up.
Okay, thank you so much.
Yes, this is the slide where they presented okay, yes, they're applying a factor of 1,000 in calculating a core. Naturally, since the final risk score is the product of lore times core, this would be overall a 1,000 multiplier in the risk score. So my question, I believe we've seen some presentations separately from Southern Cal Edison that they were applying a scaling value of 100. And I recall from the SEMPRA ramp recently filed that they were using a scaling value of 10,000. My memory may not be completely clear, but my question again would be, is there a comparable scaling value used by each of those other utilities, Southern Cal Edison and San Diego Gas and Electric?
Hey, this is Julian Summer from SDG&E. To speak on our behalf, we do have different MAVF frameworks that limit comparability, but we also have a readability multiplier that's embedded in our RSE calculations. We just, our examples as well in this presentation were illustrative, but that is included and will be, part of the RSEs in our summary spreadsheet.
And have you determined a particular readability value that you're sticking with?
Ours is 100,000.
100,000, right?
Correct.
Okay. So that's for San Diego Gas and Electric.
Correct. Thanks.
Okay, thank you. Can Southern Cal Edison give us some information?
So I think the question is the readability factor for RSE. Is that the question?
Yes.
Right. So I think one thing to consider when we consider this readability factor is what denominator are we using? Is it the full $1 million? Is it in thousands? Is it in 1 million? Right. Number one.
That would also, right? Well, so yeah. So if you back it up from RSE and just look at the risk score before determining RSE.
Okay, so you're just the question is just looking at the risk score before
the
cost. Right. Okay. So as we indicated, we have a 100 unit scale on the y-axis, similar to what is shown on this page. But when we finally calculate the final risk spend efficiency, we do multiply it by 1 billion.
Because it's you're indicating risk reduction per million.
No, our RSE is we'll just multiply by 1 billion just for readability factor.
Oh, readability, 1 billion.
That's correct.
Okay. Well, the reason I'm asking that question, as you might imagine, is that with no other consideration of how the calculations are made, these differences in readability factors can make comparison of the three utilities figures difficult.
I do appreciate that, but I think it's also important to note that each utility's MAVF is very, very different from each other. So, from a fundamental perspective, they're not comparable. It's only comparable within each utility's risk spend efficiency.
Right. Yeah, I have noted some other differences, but I'll hold off some other questions if other folks would like to jump in.
San Diego Gas and Electric, and we just wanted to second that as well, that our MAVFs are different, so it would be difficult to compare.
Great, thank you. Tom, go ahead.
This is Joe Mitchell. Can I just jump in and just answer one of something that Wendy brought up, Mussey Grade Road Alliance. Yeah, so Wendy asked if we would take out the scaling values and use a uniform value, would then they be comparable. We tried to do that with the WMPs, both in 2020 and 2021, by just taking certain risks and normalizing them and saying, okay, let's assume that we make all the vegetation risks the same or the hardening risks the same. How do the other risks compare? And even then, they're all over the map. So I think the answer is no. Even if you take out the scaling factor, there's still huge differences in the methodologies that are leading to very different results. I'm sorry, that's all.
Hi, this is Yumi from PG&E. I couldn't hear the first question, but I rejoined to be able to answer this. So the scalar that we use 1,000, even if we would make the scalar the same, the scaling function itself is different between 3 IOUs. We use nonlinear scaling function. So depending on the magnitude of the outcomes, depending on where it lies, the comparison could be somewhat different. So if all 3 IOUs were to use the linear scaling function, and also if all 3 IOUs use the same ratio between safety versus financial in terms of the weight, and reliability versus financial in terms of value of service, then it might be comparable. But even if we make all of those the same, because we are using different the value of service or the safety to financial ratios, currently it would not be directly comparable.
Yes, thanks. I appreciate that. I was just starting my questioning with the scalar number, but clearly there are other differences between the way that the MAVF is calculated. Thanks.
And if I could go ahead, this is Tom Long from Turn. Can folks hear me?
Yep, we can hear you, Tom.
Yes, I hear you, Tom.
Great, thanks. So I'm just going to follow up on that line of questions, because that's what I wanted to ask as well, and ask the broader question to each of the utilities. They've identified some of the factors that may explain the differences. We've talked about scaling factors. We've talked about some differences in the way that the utilities structure their MAVFs. I'd like to hear from the utilities. Can they identify what are driving the biggest differences in the RSE in RSE comparability among the utilities? I'd like to hear from them what they think, especially in order of importance. That would be helpful.
Let me go first. This is Yumi from PG&E. So how I think the biggest factor will be, at least from PG&E with the other utilities, will be scaling function. So if we have a consequence at $1 million or $2 million range, which is below 1% of upper bound of the range here, 5 billion. So let's say we have a consequence below $15 million, then it's a linear scaling function for us. And so our 2 million will get us to 1 risk unit. In terms of $2 million consequence will give us 1 risk unit. But if we extend the linear curve to the right of 100% of the range, then the difference between the risk scores that other utilities use will be like maybe 10 times different from what we are using. So one thing that I think we can say is that for the lower consequence values, our core value will be maybe 10 times lower, even if we were to use the same value of service or same value for trade-off between safety versus financial. So that's one biggest difference that I can see. And the other difference would be safety versus financial comparison. But it seems like we might be using, all utilities are using $100 million. If I'm not misunderstanding, all the utilities are using $100 million versus one per life. Exactly. So I think we are consistent in that manner. I think there are some differences between electric reliability financial. We use probably $1 per CMI, but other utilities are using higher numbers for that.
And then Yumi, if you don't mind, what about other factors such as discount rates for the benefits and the costs? And what about also how the utilities define their different mitigations? Are those also factors that are creating differences?
Yeah, especially in the discount factors. I don't know exactly what other utilities are using in terms of the discount rates, but we use 7% for denominator and numerator, and it will be different from the other utilities. So that will make the difference in the RSE values, not necessarily in the risk score.
And would other utilities care to comment on what are the biggest drivers of differences in the utilities' RSE scores?
This is Jillian Summer again with SDG&E. I think similarly, our thought is that the MAVF components in terms of both the scaling and the weight differences are a big reason for the difference. And then I think you mentioned this, Tom, in terms of infrastructure differences or how mitigations are implemented. I could see that being a differentiator of what goes into the mitigation, because that will ultimately affect cost. It could affect efficacy. And we know those are the components, or two of the components of the RSE.
So this is Gary from Southern California Edison, just echoing what Yumi and Julian have already indicated, but note that SE does not have a gas reliability component. So already there is a mismatch in terms of how much weight is allocated to, for example, electric reliability. I know SE is using customer minutes of interruption. I'm not particularly sure what San Diego may be using. They may be using SAIDI. So that could be a source of difference. To the extent of different mitigations, I think there's current working groups, for example, the cover conductor effectiveness working group, trying to align on the effectiveness of cover conductor, right? So there is effort to align from that perspective.
I do have a quick clarifying question that I wanted to ask SDG&E. It's clear from the presentations that PG&E and SCE, or PG&E uses a nonlinear scaling function, and SCE uses a linear scaling function. SDG&E, do you use a nonlinear or linear scaling function? And have the weights of the attributes changed at all since the 2021 WMP?
Sorry, looking into this. Hold on one second. Be right back. I don't believe that our MAVF has changed, if that kind of ties into the question. Otherwise, do you mind repeating it?
Yeah, so essentially wanted to see what the scaling function is for SDG&E in terms of MABF, if it's linear or non-linear.
Okay, sorry, now I understand. It is linear, and no, we don't have any changes in
Okay,
the frame you asked about.
sounds good. Thank you for the clarification.
No problem.
And Jessica, we can go to Chris's Q&A question in the chat box.
Sure. So Chris asks, this is a question for all utilities, asking if each of the utilities can describe if the RSE verification and effectiveness process and initiative selection processes presented today apply to all utility risk program management, or are they specific to specific risks or WMP risks?
I can go first. This is Devika from PG&E. The RSE verification process that I talked about today was specifically for the initiatives presented in the Wildfire Mitigation Plan for 2022. But we hope to take learnings from that and then expand that as feasible.
This is Chris Vias with SCE. Chris, in answer to your question, what I presented on today was the general process for mitigations in the areas of wildfire and PSPS. While the general aspects are utilized in other arms of the company, it may not be precisely the steps as I outlined them today. But we focused on wildfire and PSPS given their importance and profile in the risk arena right now in California.
This is Nisha Menon from San Diego Gas and Electric. So our MABF and our RSE processes, those are company-wide. But our tools that Jillian shared in the presentation, the Wildfire Next Generation System, those are specific to wildfire hardening. But RSE processes company-wide.
Great, thank you for the responses. And James, I have a quick request. I believe Vincent from the attendees is raising a hand because he wants to be moved over to the panelists side.
If you're comfortable with that, I'll move them.
Yes. Thank you.
When you get a chance, I did have a second question I didn't get to ask.
Yes, Wendy, go for it.
Okay, great. So I can put my camera on. I wanted to talk about mitigation effectiveness and, for example, what if how do I say this? Let me give a specific example. Contact from foreign objects, from balloons in particular. It's my understanding that there's been less of a risk for contact from balloons on the last 2 years, more because of what's happening in the industry, that helium was very hard to find or hard to obtain for celebratory balloons. And so I believe there may have been a lot less incidents in the last couple of years, just because there may have been a lot less balloons out there. But in addition to that, I myself am involved in an IEEE standards task force developing a standard trial test standard for celebratory balloons to either pass or fail as conditions where if they pass, they have a much chance to cause a fault on a line. So my question, and I wanted to give this example because what happens if there's less risk from one of your risk drivers completely outside of your control, but you're aware of it, that there are less risks. So the mitigation effectiveness, because the mitigation effectiveness that you're trying to assume is from the actual programs and projects that you are putting forward. But what if there's other forces that you're aware of that perhaps are making those risks less than historical risk? Can you all three utilities speak to that?
Hi, Wendy. This is Jimmy. So let me attempt to answer that question. My understanding or my take on that is that effectiveness is not changing depending on the risk level, but then the risk itself will go down for that particular driver over time. And so given that we are calculating the particular driver's risk in terms of the frequency and the consequence associated with it based on historical 5 to 6 years of data, over time, if there is a trend in reduction in those numbers, then it's going to be reflected in the future when we update our audits. So that way, even though effectiveness is, let's say, the same as like maybe 50%, the risk itself is going to be reducing. So the risk reduction of our mitigations will be reducing as a result.
Does Edison or STG want to add anything? I appreciate that, Yumi.
Hey, Wendy, this is Eric from SCE. I just want to echo what Umi said in there. So essentially, we're looking at two things here. The first part is, does the problem exist? In our modeling approach, we are looking into that portion from our probability of ignition perspective. And that part itself is independent of the mitigation effectiveness. So give you one example, right? So if you have certain medication that treats certain disease, is regardless of whether the people has that disease or not, it's always there. So, and in our calculation, if the driver is being reduced or is completely gone, that will be reflecting our probability of ignition models, therefore reflecting our risk quantifications.
Thank you. Does SCG have anything to add?
I think we're kind of aligning with SD and PG&E as well. And we're saying basically if we're seeing fewer balloon contacts, that the pre-mitigation risk score will also take that into account. And it's also, if the driver is reduced, that data set will also tell us that. And that's going to be incorporated in our POI models. So I guess it will be reflected in our modeling and the way we look at the data.
Can I ask the three of you, have you seen that in the 2019, 2020, 2021? Have you seen a trend for the risk, the balloon driver risk trending downward, if you remember?
We're looking at our last few years of data, and there has not been, sorry, this is San Diego Gas and Electric. We have not seen a significant change on the balloon contacts data.
Yeah, similarly here from SCE, we're now looking to the reliability data, and we don't see the downtrend word yet.
PG&E, do you know?
I have not personally looked at it, but we can take a quick look and see whether we have that trend.
Okay, thank you. I can let others go now.
Thank you for that question, Wendy. Next, let's go to Joseph Mitchell.
Hi, Joseph Mitchell, Mussey Grade Road Alliance. Back to the MAVF functions. There is a maximum range for all of your risk attributes. We've been through this in the WMP reviews, but just to review what the state is now, what are the, do you apply a cap on your risk values at the maximum end of the range, or are risks or risk events allowed to have values outside of the maximum range? And that's to all three utilities.
Thank you, Joseph, for the question. This is Yumi from PG&E. We have started to remove the cap in the GRC. So up until 2021 WMP and the ramp, we used the cap. So our scaled unit didn't go over 100, even though the natural unit consequence went over the cap. But in the GRC in June this year, we removed the cap, and so the scaling function goes above 100 if the natural unit goes above the upper bound.
Hi, this is Gary from Southern California Edison. We do not have a cap.
The San Diego Gas and Electric. We do allow to go over the ranges, but we are still kind of reviewing this with our enterprise risk management team. So we can double check and still get back, but yeah, we do go over the ranges.
All right.
All right, Tom, go ahead.
Thank you. My question relates to the topic that all three utilities addressed in their presentations regarding how they use the RSEs in designing their portfolio of mitigations. And I wanted to ask specifically to, well, first I'll note that in SDG&E's presentation, if I understood correctly, when they were discussing their use of the WINGS model, they were saying one of the things that they were able to do with the WINGS model based on the segment level analysis was it would help inform their decisions about the scope of the mitigations they would be using. That is how extensive the program should be. And so, which I think is a positive, which I want to give kudos to SDG&E for using their WINGS model that way. I think that's valuable. I wanted to ask PG&E and SCE, because I didn't hear it in their presentations about how they use RSE. Are you using RSE to help you decide the scope of the program, given that there's diminishing returns as you extend a mitigation program deeper into your system, which would be reflected in declining RSEs for different tranches? So maybe we could start with PG&E.
So Uzvela from our enterprise risk team at PG&E raised her hands. Could you make her as a panelist so that she can answer?
I did that. She should be joining as a panelist.
Thank you.
Well, I tried to promote to panelist. It doesn't look like she's moving. I don't know if that's a problem with the client side on her end or not. I can allow her to speak at least. Hopefully they can unmute themselves.
Hi, good afternoon. Can everybody hear me?
Yep.
Perfect. Thank you. This is Ujwala Gupta. I'm with the Enterprise Operational Risk Management team as the director. I'm happy to share PG&E's position, but I would also like to invite Brad Colling. If you could please make him a panelist as well. He is our system hardening subject matter expert, and he's here with us as well to talk about how RSEs are being used for system hardening project planning. So I'll give an overview and then I'll pass it on to Brad if that's okay.
Sounds great.
All right, thank you. So PG&E is continuing to evaluate how we are using RSEs most effectively in a decision-making process. It is still very much in something that we are working through, and it's evolving. We are continuing to expand the development and the reporting of RSEs to inform our decision-making. Currently, they can be used in one of the two ways. First is that RSEs are being used at a program level to understand their relative prioritization with respect to each other. And secondly, specifically for system hardening, that's where Brad Colling and his team are using RSEs to identify and prioritize the different projects within system hardening for implementation and for decision making. So for example, in that specific use case, they are being used to select between different system hardening alternatives such as line removal, overhead system hardening, undergrounding, etc. So it is still very much an evolving process. And then apart from system hardening, currently we are using them at an overall program level to provide guidance. Does that help?
Oh, yes, thank you. I guess a follow-up would be, apart from system hardening, are you using it for other programs in the wildfire context to help you decide the scope of your programs?
So apart from system hardening, like I said, in the context of WMP, wildfire mitigation, we're using them at an overall programmatic level to identify where one program is seen as more beneficial than another for high-level planning purposes. And I'll invite Brad to provide more context and color.
Yeah, can you hear me?
Yep.
All right. So thanks everybody. I haven't been here all day, but give you a bit of a context. What she's trying to impart is that for the system hardening program, I'm going down line by line, span by span to develop several different scopes of how we harden, kind of how you described it earlier, for the area, and to determine the right solution for hardening within that area. Most other programs are not going to project by project level for that RSE calculation, but more at the full program level to decide how much investment into that program is warranted given the amount of risk we expect to reduce within that program. So that's how the difference is for PG&E.
Thank you, Brad. Now, does that mean that you're using RSE calculations at a pretty granular level then to make those decisions?
Yes, I'm looking, when I do our system hardening program, we impart various initiatives, whether it be removal of the line, the remote grid initiative, overhead, relocation of overhead, and relocation of overhead to underground. Those are all being looked at for the specific area and the specific needs for the system. We're also looking at secondary risks not part of the risk model, such as ingress and egress, tree fallen risks that could break the line, and PSPS benefits to better understand what's actually needed in that area in order to mitigate as much risk as possible. And then once that RSE is calculated, we have some rules and some decision points made when we review with the Wildfire Governance Committee that we have, that we actually make the decision on what is the appropriate scope for this area and how to move forward. So yeah, we use that for all of that.
Okay, and are these they sound like they're quite granular, these RSEs that you're using. Are they the same as the RSEs that are being presented in your, say, your GRC and your WMP, or is this something that's internal?
It's an internal, it's specific to the cost for that work at that point and the specific wildfire risk in that area. We are moving towards morphing this into more of an MAVF risk reduction into our 24 and beyond plan, so that we have a more full look at the overall risk that may be mitigated through that same system hardening work, and not just the wildfire risk a reduction. But yes, it's very granular down to specific segments of the circuit that we plan to do the work on.
Okay, thank you.
Can I actually ask you to repeat the specific programs? I was trying to take notes and you were saying it so fast. Could you actually?
Yeah, no worries. Understand that system hardening is a complete solution for the wildfire risk mitigation within that area. And so for our system hardening program, our decisions first start with the identification of removal or remote grid opportunities within that segment of line. And then we move on to opportunities in undergrounding, overhead relocation, and then overhead harden in place to achieve that wildfire risk mitigation. Those are the main initiatives, but understand that there are benefits outside of that that we also achieve for other programs, such as we will replace all the non-exempt fuses and equipment within the area when we do this, and others of that like. So those are not calculated in the current overall risk spend efficiency that we use.
And when did you just start doing this? When did you actually start looking at this level of detail?
We started having a more robust discussion and a long-term risk benefit calculation early this year to develop our 21 to 23 work plan for system hardening.
Brad, I have a follow-up question. Are there any sorry, I'm getting some background noise. Sorry, this is going to be a little bit loud for the next few seconds. Are there any intra-program collaboration within PG&E to extend this usage of granular RSE for decision-making to other programs?
I am not part of it directly myself, but I have been part of and seen discussions with the other programs with the Wildfire Governance Committee, steering it towards having that more granular risk spend efficiency. However, when you're talking about component analysis, it's really not as effective as to do this type of calculation on a project by project basis. It's more of a program level base. Hey, what amount of risk associated with these units, using the risk model to direct that work would we hope to achieve? And then decisions as you start, as what we discussed earlier, on that diminishing return on that risk reduction would be had at a more of a program level based on what was remaining versus a line by line view.
I want to thank you for that. I wanted to give Edison a chance to answer my question too about whether and how they're using RSEs to make decisions about the scope of their wildfire mitigation plans, recognizing the diminishing risk reduction you get as you extend the program deeper into your system.
Hi, Tom. This is Chris Vias with Edison. Thanks for your question. As I had presented on, we use RSEs as an important factor when we're determining in that 4-step process I outlined for decisions in wildfire and PSPS, when we're determining what mitigations we're going to choose, and we may not necessarily scope directly using the RSEs. And I'm the expert on the scope part of it, but we absolutely do consider risk reductions and the costs of the mitigation as factors when we're determining scope. And we have a whole host of other factors in this complex decision-making process that our management has to consider, such as resource constraints and the like. And if Eric on our team has anything to add, I'll toss it over to him.
Yeah, thank you, Chris. Thank you, Tom, for that question. I think that's definitely an important question for us to look into. And I want to first answer the first part. You mentioned that the diminishing effects. So we always have that diminishing effect when you're further going down to the mitigations and going down to low risk segments. But the issue here is that the diminishing effects will impact the RSE because now your risk will be rather lower in RSE, but that impacts all your mitigation programs. So, and please don't hear that when we look at RSE, RSE is a measurement to compare amongst all the different programs, right? And the diminished effect may impact RSE, but not necessarily impact in comparison amongst all the different mitigations. So with that being said in there, because we are looking to all the mitigations by their relative nature. So which one has the max potential to reduce certain drivers. And not to mention that there are some programs that may show high RSE, but it will never address certain drivers that we have to address. Hope that answered your questions.
Well, it's interesting. That's interesting, Eric. It's interesting, an interesting insight into how you think about it. Just to give an example, if all of the pre-mitigation risk scores, if all the mitigations are showing very high, this is what I should say, if all the RSEs are showing very high values, let's say 100, and that's a high value, and then all the mitigation, you've done the work and you've done a great job, and now the RSEs are all down to 0.1. Or maybe one is 0.5, and another one is 0.1. That doesn't mean you doesn't necessarily do the one at 0.5. Maybe it's time to just stop doing the mitigations because you're not getting much value for you've extended the mitigation far enough into your system to get, for it to be cost effective, and it's now come to a point where it's not cost effective anymore. Is that? Because I guess my point is I'm not sure I'm understanding this relative analysis. I was trying to give an example of where one mitigation could be 5 times more cost effective, but still be so low as to not be worth doing.
Yeah, that's a good point in there. So, I always want to say here that RSE is a measurement of whether you are efficiently, reduce risk given the same amount of, dollar amount here, right? That's what it means, RSE. But it's all relative speaking here. So another point here is that when we look into risk, there are 2 things we're talking about here. One is relative risk, one is absolute risk, right? So when you look in 0.05 and 0.1 and 0.01 in that example, what does 0.05 means? And you have to translate that into how much impact you're going to our customers. For example, what is the actual CMI going to be, and how many people will be impacted? And all those has to be considered in the whole decision-making process.
Okay, thanks. I'll lower my hand now. Oh, I guess it was lowered.
Thanks for that question, Tom. Joseph Mitchell, go ahead.
Yes, this one's for PG&E. Regarding your RSE governance process, you rank your estimates as low, medium, or high. Do you have any sort of quantitative means for calibrating this low, medium, high, or qualitative? What does low, medium, and high mean in that context?
Hello, this is Devika. Can you hear me?
Yes.
Great.
So the low, medium, and high this time around is going to be qualitative. And it's going to be based on, so for example, for effectiveness, it will have its own scale. And we will keep in mind what is, low being where we feel like there's a lot of room for betterment for that particular initiative. And I think it's mostly going to be relative to an initiative that we feel has an effectiveness that we are most comfortable with. So they're going to be all relative to each other. It's qualitative, it's SME based and discussion based. And really where we get our confidence on that is we're going to have a quorum that's going to decide on it. So very much qualitative, but based on the input of experts.
Thank you.
You're welcome.
Great. Thank you for that question, Joseph. Let's see here. I have a question to ask SCE and SDG&E. So in the PG&E's presentation earlier, PG&E was able to clearly define how the change in likelihood of risk events are calculated for mitigation initiatives versus control initiatives. Can SCE and SDG&E expand on their processes for calculating the change in likelihood of risk events for mitigation versus control? And we'll start with SCE.
This is Chris Vias with SCE. I'm sorry, my audio cut out for a second. Could you please repeat the question?
Yeah, of course. And James, if you wouldn't mind pulling up slide number 11 in PG&E's presentation, that would be a good visual aid for us. Yeah, so I'll repeat the question. In PG&E's presentation, it was clear how the likelihood of risk events or the change in likelihood of risk events were calculated for control versus mitigation initiatives. Just wondering if SCE and SDG&E can give some insight on their processes and if there's a difference in how that's calculated.
Hi, this is Chris Vias with SCE. I'll go first, and sorry again for the short delay. They're just having a little bit of audio issue. The different parties, and we've seen this in the risk-informed decision-making OIR before the Public Utilities Commission, seem to have somewhat different definitions, working definitions on what is meant by a control. And so actually in the upcoming phase 2 of that risk OIR, one of the tasks that parties will be taking up is to see if there can be more consistent definitions for terms like control. In particular that one, because in that proceeding, parties had different views. So for one party to say, I score controls, can mean a different thing than another party saying, I score controls, a utility party.
Okay. Well, in your interpretation of a control program, is there a difference in the approach of calculation?
In a difference in calculation as between what?
The likelihood of risk events for a change in likelihood of risk events for mitigation versus control.
I'm going to also ask Gary Cheng to also join me in responding to this. If the answer, I guess it would have to be a little bit more specific as to what you mean by control here. What are you sort of asking here on control? And I'm sorry, I'm not trying to be, I'm just trying to really understand this question a little better.
Yeah, no worries. So I know in PG&E's presentation that this is something that's come up more recently, and here on the mitigation side, we can see that we're looking at the percent effectiveness times the likelihood of risk event, and then for the control, there's a direct calculation or estimate for the per work unit. So I'm just wondering if there's a general distinction between the two, where to the approaches.
Well, look, in our last, well, I'm going to ask Gary Cheng if he has a response on this.
So maybe more clarifying questions is, Alan, is when you refer to control, are you referring to something that's currently being done or currently being as part of some geo regulation?
Let's say for geo regulation, it's a work that's it's compliance required.
Gary, I can take this as it relates to compliance items. So SCE does not score for example, for purposes of its last ramp, don't score compliance items. And there's reasons for that. Sorry, I just cut out again. There's reasons for that. SCE, like other parties, we don't have the option really to pick and choose what laws we will and won't follow. And so we consistently have stated in forums like the risk-informed decision-making rulemaking before the commission that if there is a specific area that stakeholders believe should be scored, we were ready to discuss that, but we don't, as a general matter, broadly across the entire span here, we don't score compliance controls. And to our knowledge in the risk OIR, no party took us up on that option that if there's something specific that you feel is lost by a specific area where you think compliance should be controlled and why, we said we're ready to discuss that, and no one took us up on that. And as I said earlier, the definition of terms like controls is going to be taken up in the upcoming phase of the CPUC's risk OIR. And just to kind of maybe also just tie this up, the key point here is that the intent of RSCs is to help in assessing mitigations that are in some ways optional, meaning that they either can or can't be selected to be carried out in order to address risk. And yet, if you were trying to provide an RSC for something you're obliged to do by law, then you're trying to do something where there isn't necessarily any something can or cannot be selected, because it has to be selected in order to comply with the law. And lastly, I just note that when that law or regulation is enacted, the legislature, per its responsibility, weighs the benefits and the burdens to affected parties of complying with the law or reg. And they take testimony, they build a record, the testimonies from various sources, including experts, they enter documents into the record, and they carefully balance all the various crucial interests in order to figure out the best way and then pass the legislation that is the best way in the legislative review to carry out the legislative intent. And we feel, and we've said this consistently in the risk OIR, the utility can't place a value or in other words, second guess the legislature by trying to assign relative values of complying with mandatory laws and regulations. So I hope that helps with regard to compliance items.
Yeah, thank you for that, Gary. And does SDG&E have a similar stance, or is there something else to add?
Yes, just to chime in, this is Jillian Semmer with SDG&E. We do have a similar approach as PG&E in terms of baseline conditions. We do calculate RSEs but otherwise same approach with control versus the mitigation.
Okay, got it. Thank you so much. And let's go to, let's see here. Jessica, I see that we have a question from chat. Let's take care of that, and then we'll go to Wendy and then Tom.
Sure. So yeah, this question is from Sarah Thomas of CPUC Legal Division. And this is a question for Chris Bias of SCE. So going back to when you were addressing different definitions of control in the risk-based decision-making proceeding, can you explain how it is being addressed? Is it happening formally in the proceeding?
Yes, and to clarify, it was raised in the proceeding and it has been selected to be considered in the upcoming phase 2 of the ongoing risk-informed decision-making proceeding before the commission. So it hasn't been treated yet in that proceeding. Parties have raised the issue that we seem to have different definitions. The staff in workshops, I think, agreed with that viewpoint that there are different definitions. And I can't give an answer as to what is the outflow from that because it hasn't happened yet. But it will be occurring in phase 2 of this rulemaking, and phase 2 is expected to start in earnest after the new year.
Great, thank you. Wendy, go ahead.
Thank you. I have a couple questions, but I'll just say one and give Turn a chance after that. I specifically do want to bring up about the joint covered conductive effectiveness working group and ask when exactly did that group start, and who all is involved in the group, and what's the time frame, and is there a report that's going to come out of that?
Hi, Wendy. This is Chris Bias with Edison, and our experts in that program are not necessarily on audio here today, but we can try to get back to you with more information on what's the timeline and scope with regard to that effort. I believe it started out as an OEIS directive, but I'm going to have to defer to our experts, and they are not they're not on this call right now, to my knowledge. So this workshop line, to my knowledge. So.
And did you receive my data request?
Yes, we did, and we're working on a response to it.
Okay, thank you. Okay, let's go to Turn, and then if there's time, I have more questions.
Yeah, go ahead, Tom.
Okay, thank you. If I could just briefly follow up on Wendy's question. And Chris, I know you may not have the right people, but this joint cover conductor working group, is it a private utility only endeavor, or does it have meetings that include others? And this is something I wasn't aware of.
I appreciate your question, Tom, and I simply can't answer on behalf of SCE with regard to that. I don't have those details. I believe it is utilities only, but you know, Tom, I'm pretty sure it's utilities only, but you know, again, we can get that further information to you as a follow-up.
Okay, thanks.
Hey, Chris, Tom.
Oh, sure.
Hey, Chris and Tom, this is Paul McGregor from PG&E. I'm not scheduled to be on the panel today, but I think I can maybe help you guys with this answer. The covered conductor joint section is actually one of the remedies that came out from the OEIS, part of the WMP remedies. I believe the participants are all 6 California utilities. So that would be PG&E, SCE, SDG&E. The meeting has been going on for a good few weeks now. I know that they've got a number of initiatives going on, like looking at how each of the utilities score covered conductor, how of them apply it, and also looking at getting expert opinions with regards to the effectiveness of covered conductor in certain failure modes, you know, with regards to height of trees, height of fall, et cetera, et cetera.
Oh, that's really helpful, Paul. Do you expect there's going to be some sort of work product or something for the rest of us to review out of this?
I don't know the outcome. I know that it's been sponsored by the OEIS. I'm not the project manager. I know my team members on it. I wonder if perhaps a team member from the OEIS could speak to the specifics, the desired outcomes associated with that particular work stream.
Yeah, I see that Andy's in the panel. Andy, do you have anything to add? And Wendy and Tom, we can always respond with an email back to you.
Hi, yeah, so what Paul said, the group is limited to just the utilities. It includes the big 3 IOUs and the SMJUs. There's more information in terms of what all they're looking at in the November 1st reports. And they're supposed to continue reporting on sort of their findings within the Wildfire Mitigation Plans. So there will be more information in the 2022 filings.
Thank you. That was just a follow-up. Is it okay if I ask another question now?
Yeah, of course.
Okay, thank you, Alan. So I was going to ask, I know the utilities have different views as to the appropriate discount rates to use for the numerator and the denominator of the RSE calculation. And I'm not asking you to get into the debate about that. But my question goes to the issue of comparability. Is there any reason why it would be a bad idea to have uniform discount rates being used by the utilities in their RSE analysis? You know, assuming it needed to be, maybe it needs to be decided by a regulator, a decision maker, if there are differences. But is there anything inherent in the way, in the differences between the utilities that would argue for a different discount rate being used by different utilities? Can we start with maybe PG&E on that?
Sure, this is Yumi. In PG&E's case, we believe that after-tax weighted cost of capital is the right discount rate to use when we are doing cost-benefit analysis, not just for the mitigation, but any other programs that we do. And so I think that the average like WACC, after-tax WACC values are different for each utility because their rate on return and other things are determined for that specific utility. So I think that there could be differences depending on what utilities are required to earn.
Okay, those differences would be relatively minor, but if it coalesced around weighted average cost of capital, that would be roughly comparable among the utilities, I think. So again, my question to the other two utilities would be not, do you agree with PG&E's approach or whatever? That's a different question. My question is there any reason why, anything about the differences between the utilities that would argue for different discount rates among the utilities?
Tom, this is Chris Vias with Edison. I think that, you know, each utility has its justification and good reasons for what it applies. I think what the goal that you're talking about is exactly the kind of thing that's being worked in the risk-informed decision-making framework, so that it ultimately is workshopped, and perhaps there will be some guidance from the regulator on what such similar items should be. But if you're asking today, would we just unilaterally pick what PG&E's approach is? We can't say that.
Yeah, no, that's not what I'm asking, but I appreciate that you're looking for guidance, so that's helpful to know. How about SDG&E?
Tom, do you mind stating the question again? I just want to make sure I understand it.
I'm not asking what is your proposal for the
Right.
discount rate. It's do you see any reason why we shouldn't, if the regulator can decide or some other way we can come to a conclusion, is there any reason why the discount rate should be different among the 3 utilities?
I will confess to not being a financial expert, but I do believe that there's probably some variations and factors that do affect the different utilities. And so maybe there is enough overlap, but I'm not sure that that is correct.
Yeah, I mean, Yumi spoke to that there are differences in the cost of capital.
Exactly.
But those are not particularly large differences generally, anyway. Okay, well, thank you, everybody. I'll lower my hand.
Thank you, Tom. Wendy, go ahead.
Thank you. That's another question about mitigation effectiveness. So I know that there's a lot of things happening in pilots, I believe, for new programs that, you know, from a power engineering perspective, may be able to reduce the risk of faults and ignitions. And I wonder, I guess I struggle with how the utilities can be quickly getting, you know, lessons learned and from pilots, or maybe not even pilots. I mean, 10 years ago, a decade ago, I was involved in what was called smart grid deployment, and a lot of grid modernization was happening. So I guess my question is, it seems like there's a real heavy focus on these big capital projects, like cover conductor, undergrounding, but how can the utilities focus more on other ways to reduce risk of faults and ignitions, and come up with appropriate mitigation effectiveness for these areas?
Wendy, this is Chris Vias with Edison. I appreciate your question. One thing I would just note as an initial response is that, you know, for example, use covered conductor. That is not the only way that the utility is seeking to mitigate against or mitigate to lower the risk of ignitions. There's vegetation management and other programs. So it's not just saying this is it and, you know, we're just going to do this and that's all it is. It's, you know, part of trying to find out what's the best way to have a suite of mitigations that will address a risk. In the case of wildfire, what will address something, you know, to an effective degree and can do so in a way that moves with the appropriate expediency in doing so. And in terms of solutions that might be other ones, you know, obviously the utility is always looking at this, as I alluded to in my presentation, you know, as technologies mature, and by technologies, I mean, you know, solutions. We are always looking at that, and particularly, you know, once pilots and other efforts have occurred to validate, then we examine whether that can be, you know, a way to augment or replace as a mitigation. But I hope that answers, but you know, it's certainly, when you say, your question was if there's these big capital projects and can't other things be done, I would say that we look at alternatives. We looked at alternatives when we decide on the capital project. We reassess, as I indicated in the general process. And in the case of a large capital project like covered conductor, it is not the only thing. We do other things in order to mitigate. And I'll ask others then, the other utilities, to provide whatever response they wish.
Yes, this is Jillian Stemmer with SDG&E. I'm sorry I could not see who was speaking and didn't capture your name, but we agree with that approach. The reason so much of the discussion was about grid hardening initiatives like covered conductor and undergrounding programs is because of the large capital expense associated with them. But we do have a lot of others. I know they were broadly included into asset management and vegetation management, but there's a lot more programs or initiatives within the programs. And we're looking at new technologies, how they get deployed. Lessons learned are part of our routine WMP and large reports. So we're continuing to learn from them. Equipment gets replaced as we do repairs associated with inspections. So, fuse replacements didn't get a lot of discussion, but we are looking at a lot of other smaller programs, I guess smaller relative to, cost of capital or risk reduction.
And folks, just to add to that a little bit from PG&E's perspective, I agree with both SCE and SDG&E's positions on that one. Obviously, the big capital intensive programs tend to be the system hardening, such as covered conductor or undergrounding initiatives. On the O&M side, we do have some comparisons, some working together. Again, there's another joint OEIS sponsored remedy on enhanced or expanded vegetation management, that those teams are in play as well. But also with regard to developing technologies. And as you're all aware, there are technologies out there that the utilities continue to evaluate, such as falling conductor or fast trip settings, also known as our enhanced power safety settings program. That's something that PG&E has found success at. From my previous career, I know other utilities have introduced fast curve settings, slightly different, but again, making use of the technologies that we have from our sectionalization for equipment to control the sensitivity to faults and outages on our line that could result to ignition. So a lot of things going on in the developing technology space. I think it was my colleagues at SDG&E that mentioned it, that because we tend to do these in smaller and pilot type programs, obviously the effectiveness is something that we need to make assumptions for on the grander scheme of that. I know PG&E has had discussions across DRs about the effectiveness of some enhanced technologies, developing technology programs that we don't have that detailed outlook for because they're done on a small or pilot type approach.
Thank you, everyone.
Thanks, Wendy. We appreciate the question.
Thank you, Wendy. And Max, go ahead.
Thanks, Alan. Now, I should say, I know we were supposed to, this is Max Henry from Lumina Decision Systems. We're working with level 4 on a sort of evaluation of the use of RSE by the utilities. I know that I had not previously submitted my questions. I just want to make sure that's still okay. I have a couple of questions. I noticed that PG&E was in computing RSE, and looking at the potential impacts of wildfires, you are projecting into the future that the risks are going to be increasing, which seems to make sense. I just wanted to check with the other two electric utilities whether you are also doing that or whether you plan to do that rather than just basing the risk on historical wildfire frequency and magnitude.
Max, this is Jillian Semmer with SDG&E. We do also account for potential increase in risk in the future. Climate change could be one of those factors that may increase future risk. But we also balance that with accounting for ongoing mitigations that might offset that risk.
Sure. And can you talk a little bit about I mean, I know it's hard to get these sorts of projections about how the risks might increase. Is that something that you can talk about?
Max, we're still evaluating that. We do have a climate vulnerability assessment that is ongoing, and we're going to keep looking at that and the outcome of that assessment, see how it might impact our decision making. I don't really have more details for you right now, except that we are continuing to keep an eye on that.
Okay, thanks so much, Julian.
Hello, Max. This is Paul McGregor from PG&E. And just to try and give you a little bit of additional information on this one, you'll see as we go through, by the way, welcome to the team. And you'll see as we go through a lot of these discussions, there are references to other CPUC sponsored initiatives. There was an initiative last year, the Climate OIR, not sure if it's concluded or not. And some of the members would have been on that, where each of the utilities did develop an outlook for what climate change or climate adaptation might look like in the longer term. Obviously, the longer we look out, the wider our uncertainty gets. But obviously for PG&E's perspective, we have a particularly large service territory that is susceptible to changing in the climate, changing of weather patterns, changing of temperature patterns, sea level, etc. So through that climate OIR, which I invite you to do some research into, you would get an opinion of what the utilities see as far as changes in the future is concerned.
I appreciate that. Thanks so much, Paul.
Hey, Max, this is Eric Wong from SC. Thank you for that question. When we look into this issue in today's quantification, we start out with our current risk values and then overlay compare different mitigations. The reason being, some of the mitigation may be start deploying early in the year, and some may be starting later in the year, and it depends on the schedule. And that's why when we look into the mitigation, we want to have a uniform baseline to start. And given that, we're also exploring potential looking to climate change may impact our consequences in the future, and also we want to look into from the potential, in particular, the population perspective, because aging infrastructure will have the impact to those.
I understand. Thanks so much.
You're welcome.
Thanks, Alan. I do have a second question. If you have a long line of others, I don't want to take all the time. But...
go for it, Max.
Okay, so I understand that wildfire obviously has quite a variety of consequences. Acres burned, people evacuated, human injuries and fatalities, structures, air quality, and so on. I guess I'm curious about how each utility maps from those attributes or those consequences, let's say, into the multi-attribute value function attributes of safety, reliability, and cost. And let me know if you think this is out of scope for the current discussion, but if you think it's appropriate, I would be quite interested in hearing a little bit more about that. I didn't see that in the earlier presentations.
This is Yumi from PG&E.
Yes.
Let me just describe how we currently do in the wildfire time. For financial consequence, in the natural unit consequence in dollars, we include number of structures destroyed estimates per fire, and multiply that with $1 million per structure universally. And also we add suppression cost. So based on the acres burned, we apply, like, I believe it's around $1,000 per acre estimate coming from CAR fire data. And so we just add them together to come up with a natural unit in dollars. And then that will go through our scaling function. It tends to add more because it hits the non-linear scaling function part. So yeah. So that's the financial part. Reliability portion is looking at the data from our historical fires, the reliability consequence in terms of the customer minutes interrupted from the fires that were initiated from PG&E's ignitions. So we have that historical data to fit the distribution around it and come up with the distribution, probability distribution of reliability consequence in customer minutes interrupted. So that's included in there. For safety, we look at the number of fatalities from historical fires. We use not only PG&E's data, but all of the large destructive fires in Northern California that happened since 2015 to enhance the data set for the more catastrophic fires. Use that to come up with equivalent fatality, but then we also recognize that there are some data that's missing in the data out there around number of injuries associated with each fire. And so we add some factor to account for that data quality issues around the number of injuries. So we add equal number of injuries as the fatalities as well, and then add them together to come up with the natural unit in equivalent fatalities. I didn't mention in the slide back there, for serious injuries, we assume 0.25 factor to convert into the fatalities, just like any other utilities as well. So that is the basis of the safety consequence in natural units. And then, of course, it goes through our scaling function because it's catastrophic. Usually, for the large outcomes, it's more heavily weighted than small one fatality through our non-linear scaling function.
Thanks so much. That's very helpful. Did you say something about the smoke and air quality issues? I'm not sure if I caught that.
We did not add any safety consequences from smoke explicitly.
Okay. Very good. Well, thanks. That's helpful. And do you have some documents that describe that I could look at?
Oh, the one that I just described?
Okay, it explains that. Okay, good. Thanks.
So this is Gary from SCE. Thanks for that question, Max. I don't know if the moderator could pull up SCE slide 7. Which does directly answer this question in terms of how we look at safety, financial, and reliability in terms of converting the output of a Techno-Silva model into natural units. And it's very consistent with what Yumi has just indicated as well.
Thanks.
This is Nisha from SDG&E. And our methodology is also evolving. We're following the Techno-Silva output and considering other models. And we can also share our MAVF framework after this or when the slides have been shared.
Very good. Thanks so much. I really appreciate all your input.
Hey, Max, this is Joseph Mitchell from Mussey Grade Road Alliance. I just wanted to point out that there is a parallel set of workshops, wildfire risk estimation, being facilitated by OEIS, and it's meeting periodically and it's discussing exactly these issues. Andy is on, and were those sessions recorded? We've had a couple of meetings so far.
Joseph, I can answer that. Those meetings are not recorded. There will be some meeting minutes that'll be distributed, but we're still finalizing the formatting of those meeting minutes.
Thanks.
Thanks. Appreciate that.
All right, Max, did the utilities answer your question sufficiently?
Yes, thanks so much.
No problem. We have time for one more question. Does anyone else have a question they would like to ask? If not, I will proceed. All right. So this one is going to go out to all three of the utilities. I just wanted to gain an understanding on how the RSEs and the mitigation effectiveness of overlapping and compounding initiative efforts done, and how does this affect decision making? Maybe PG&E can go first. I know for system hardening, we're talking about very granular level, segment level RC calculation. So for some segments, there might be more than one initiative being deployed. How is the RSE and mitigation effectiveness calculated when there's a compounding effect occurring there?
I can attempt to answer, and maybe Paul, you can chime in. So for system hardening, if it is applied for the same location with, let's say, enhanced vegetation management, then we find that the effective incremental effectiveness that you gain from combining them together is not significant. So basically, if you sum up the effectiveness of system hardening and enhanced vegetation management, incremental is not the same as the sum of the two, right? And so I think that we made the decision that we are not going to apply on the same location for those two programs because incremental benefit is not there. But overall, when we compute the RSEs for wildfire mitigation initiatives or in the GRC for RSEs, program RSEs, to be able to compare controls and mitigation and for different programs on the same basis, we are now incorporating the compounding impact or discounting impact in the RSE calculation itself now, so that you can compare one-to-one rather than assuming that this one goes worse than the other one. But when we try to calculate, okay, if once we apply these set of portfolios to our baseline risk, how much of risk reduction they will get from the total portfolio, we sometimes try to estimate those. And when we do that, we are trying to be conservative and assume that they're going to be all having a compounding impact, and so that you don't get to reduce more risk than you have.
Understood. Thank you, Yumi. And SCE or SDG&E?
Yeah, this is Erica from SCE. So I think we have similar situation here when we look into each individual mitigation effectiveness in there, and We look into that one by itself, and we try to calibrate against all the different mitigation together, making sure that for every single one is comparable and all makes sense. And when you look into overlapping there, I agree that you cannot really use A plus B to get C, and it never worked that way. That's why we need to spend more time and start looking into the overlap impact from all different mitigations and trying to figure out what's the best way to estimate or quantify the overlap impact and come up with one general mitigation effective values. And we are looking at that part now, and it's still work in progress.
Great, thank you, Eric.
You're welcome.
And SDG&E?
This is Jillian Semmer. We follow kind of the same outline that FB and PG&E just discussed, and definitely an area of looking forward.
Great. Thank you so much. As we approach time here before we take a break, just wanted to thank all the utilities for presenting and answering questions from our attendees and panelists. At this point here, we'll take a 30-minute break. So we'll be back here at 3:10. We're going to start the panelist Q&A session. This will be a great opportunity for everyone to hear thoughts from subject matter experts and stakeholders, interveners. So we will reconvene here at 3:10. And yeah, thank you everyone for the lively discussions. All right, everyone. My clock here reads 3:10. So let's start our panelist Q&A session. Maybe we'll just give a few more seconds for people to get back to their seats if they haven't already. Great, I see Tom there. All right, so for this session here, I would like to structure it more of as an open discussion. So, you know, all the panelists here, you have the ability to mute and unmute yourselves. What we'll do here is I will kind of give some topics for us to discuss, and then we'll kind of, I just want to hear from all the panelists I have, you know, anything to add to these topics. So what we'll also do here is for those of you in the panel that's already talked and given introduction, no need for that. But if you have not given an introduction to, for yourself, please do so before answering these questions. So the first one that I would like to kick off with is a pretty broad, big question here is, how should utilities use RSE values in decision making? And follow up to that would be, how big of a role should RSEs play, and how useful are RSE values when compared to other decision making factors such as workforce constraints, permitting, and other decision making factors. So yeah, feel free to unmute and just kind of talk freely.
Okay, well, it looks like I'm the first one to unmute. Can people hear me okay? Great. So Turn would say that RSE should be extremely important in utility decision making. We view it as the best measure of cost effectiveness that we have, and that in a world of constrained resources, we need to focus the utilities' discretionary wildfire mitigation activities to where they are most cost effective. And for a variety of reasons, we need to spare ratepayers the burden of funding work that is not cost effective. And those reasons include equity, meaning not adding to the already significant burdens that disadvantaged communities face in affording an essential service, electricity, and also responding to climate change. We need to avoid making electricity rates even more unaffordable so that we can achieve our state and national decarbonization goals. You know, electric vehicles, electric heating, electric, you know, devices for cooking and water heaters. We're not going to get people to transition to those if electricity is not affordable. So we have a variety of reasons for being thoughtful about how we deploy, how we spend our limited resources on wildfire mitigation activities, as important as wildfire mitigation is, obviously. I would say that RSEs are particularly useful for multi-year infrastructure programs. We were talking about the big capital spending programs. Those have been a significant element of the utilities' wildfire mitigation plans. And in those programs, you know, work begins. The utilities start by focusing their work appropriately on the highest risk assets, and then each incremental unit of work has reduced cost effectiveness. So at some point, it will make sense for the utility to stop deploying that program because the risk reduction benefit simply doesn't justify the cost. And you know, there's some version of the 80-20 rule that applies here. You get 80% of the risk reduction by looking at 20%, by working on 20% of the assets. And you know, once we've maybe gotten to that 80% point, we need to think carefully about whether we should be continuing with the program. To use RSEs in this very important way, we need reasonably granular tranches based on homogeneous risk profiles, and I think we'll probably talk about that a little bit more later. But so I'll stop there. But RSEs are also potentially useful for choosing among overlapping mitigations, and could help in deciding the best sequencing of mitigations. I think some utilities have referred to this as sort of a loading order concept. You use mitigation X is sort of a baseline or base load mitigation where possible because it's the most cost-effective mitigation, and then you can use the mitigations Y and Z to supplement that mitigation. And RSEs can help you figure that out. And just in closing on this, I would say it's important for the utilities to use RSEs in their decision making. It's also important for OEIS and the CPUC to take advantage of RSEs as well. The highly granular RSEs that are made possible by this methodology need to be used by the regulators to put a reality check on the utilities' wildfire mitigation efforts. As we all know, as investor-owned utilities, the utilities have a profit incentive to increase rate base as much as they can. And that's one of the reasons that energy safety and the CPUC are so important. Ratepayers are counting on the regulators to ensure that wildfire work is highly prioritized and focused. Because frankly, the current trajectory of ratepayer-funded utility wildfire spending is not sustainable. So I'll close there. Thank you.
Okay, Joseph Mitchell, Mussey Grade Road Alliance, I'll go. Ideally, risk spend efficiencies are supposed to capture the actual dollar to be spent for reduction of a particular risk. Now, today we heard that the utilities brought up a number of the other factors that need to be taken into account: operational factors, feasibility, regulation, and so forth. And these are all valid concerns, but they're somewhat intangible. They're utility specific, and they don't have the same transparency of that risk spend efficiency does. Ideally, in the long term, to the extent some of these intangibles can be quantified and included in the risk spend efficiency, that would improve the risk spend efficiency. This would include being more granular, for instance, on specific project components. For instance, you have an undergrounding project. In certain cases, we have one case where it's being put under plowed fields, the other where you're trying to take it over a granite mountain. One of these is considered infeasible, but in fact, that could also be represented as just having a very high cost and therefore very low risk spend efficiency. So some of these intangible items, maybe we can't include them at this point, but OEIS should be looking as we go forward for ways where we can take some of these extra considerations that the utilities do need to apply and make them more quantifiable and include them in the risk spend efficiencies. Thanks.
I know I put my picture up here. I would like to just add my agreement with what Tom and Joseph have already put forward. I think those are all very excellent reasons and considerations, the reasons why RSE is important, and we'd like to see it developed and made maximum use of as much as possible.
Yeah. One point, Joseph, that you brought up that I feel is very is really important is that the other decision-making factors are not as transparent as RSE, where we know what the inputs are, we know what the costs are, and how those scores are calculated. Things like workforce management and other constraints, they are difficult, and having this transparency is really important for comparability between the utilities. So within that discussion that we just had, they really talked about like the levels of granularity for RSE. So maybe it makes sense now to kind of jump into that question a little bit. So maybe we can discuss what are some reasonable levels of granularity of analysis for RSEs. So for instance, is it reasonable for RSEs to achieve a level with tranches in which all assets in the tranche have homogeneous risk profiles? And really quick for everyone that's in attendance here. So a tranche is defined as a logical disaggregation of group of assets. It could be physical or human, or systems into subgroups with like characteristics for purpose of risk assessment. Yeah, so Tom, Joseph, go ahead and provide any input we have for this question here.
I'm happy to go first, Joe, unless you want to. Okay. Well, the first point I'd like to make is that the level of tranche granularity, there's already requirements that the utilities have agreed to in the settlement in decision 1812-014 adopted by the CPUC. And that's got quite a lot of guidelines about the level of granularity that the utilities are to use. So, it says, and this is what the utilities have agreed to do, is that each element in a tranche should have a homogeneous risk profile. So that's what the utilities are committed to doing. And that means the same lore and core for every all the assets in that tranche. The settlement also says that the utilities should strive to achieve as deep a level of granularity as reasonably possible, and that the level that they achieve should be based on how the risks and assets are managed by each utility, data availability, and model maturity. So on that score, when we're talking about how the utilities manage their assets, we've seen that the utilities, and we've heard discussed today, that the utilities have highly granular data about their assets that they use to manage them, particularly in deciding where to prioritize deployment of their mitigations so as to address the highest risk. And that data is available. They're using it to manage their systems, and it should be used to create tranches with homogeneous risk profiles. You see a great value. It's not just required, but there's also a great value to doing a tranche level RSE analysis, as I alluded to in my response to the earlier question, in that it can help the utilities and the regulators make decisions about an appropriate scope for an activity, particularly as we get diminishing returns from that activity. Reasonably granular tranches can also deal with some of the uncertainty issues that the utilities addressed in their presentations this morning. We can get much better and more accurate mitigation effectiveness estimates when we're talking about it at a tranche level, when the utilities have a better idea of the nature of the risk and the likelihood and core issues that they're dealing with a particular subset of their assets, instead of being aggregated across a broad group of assets where you have a significant difference in the nature of the risk. So that's going to help improve the effectiveness determinations or estimates. True, it's more effort to do tranche level RSEs, and I think that's implicit in the question you asked, Alan, but it's worth it. And I would say TURN is encouraged by the work that SDG&E is doing with its WINGS model. They're getting fairly granular with that model and making decisions about scope and which mitigations to deploy based on a fairly granular analysis. And so we've encouraged the other utilities to think about getting to that level of granularity in their RSE calculations, or even doing better than that. I will just note that we've had some issues with SDG&E on the transparency of their wings model, and particularly seeing how that model achieves the results that, we've seen results, but we really haven't seen how the model gets to those results. And we've seen it applied to a fairly narrow scope of their assets, and we'd like to see how it applies to a broader scope of their assets for comparison purposes. So I think I'll stop there and see if Joe or Fred or anybody else have thoughts.
Okay, I'll go then. So just I concur with Tom that we want to have finer grain tranches. Exactly what, just some technical feedback on that. The tranches need to be sort of right-sized for the application. One thing we've seen is that if you have inadequate statistics in a particular tranche, then the uncertainties become large. And so that's a balancing act that has to be performed to make sure that you are actually, you're not shrinking your tranche to the size that it's dominated by the uncertainties. As far as how large it should be, I think Tern presented a very nice explanation in SDG&E's ramp proceeding regarding why having big variations over a particular tranche will lead to can lead to significant miscalculation, underestimation of major risks, overestimation of minor risks. So right sizing is important. Another thing that we've brought up is that when we're talking about grouping of assets by common characteristics, this does not necessarily have to be just based on the risk calculation for those assets. It could be specific characteristics tied to risk drivers that are common for a set of assets. For instance, extreme wind. We've suggested doing extreme wind tranches to identify specific risk profiles for assets assets that would be at increased risk during extreme wind events. So I'll conclude my statements with that.
I'll just also add that in our most recent RSE evaluation of the latest ramp presented, which was the San Diego Gas and Electric and the Sempra Company's ramp, we made note that increased granularity we expect would permit a prioritization process along the lines of applying an 80-20 type of logic, where if you have sufficient granularity, you would be able to identify those portions of your infrastructure that are demonstrating the highest levels of risk that presumably would then have the most, for a given mitigation, you would get the best, most efficient mitigation of risk by applying it to those tranches that exhibit the highest levels of risk. But obviously then you need to have a selection of tranching that's granular enough that gives you some choices, that gives you some categories of levels of risk across a particular kind of asset. And I think that's consistent with what Tom and Joseph have been saying.
Yeah, I would like to bring up one point about finding these homogeneous risk profiles in PG&E's 2020 ramp report evaluation done by SPD, Safety Policy Division. SPD recommended that PG&E use machine learning or artificial intelligence techniques to identify more narrow and homogeneous risk profiles. Have any of you seen that put into practice? And yeah, I'm just wondering if you've seen that in any of the works.
I don't believe we've seen that taken forward so far. But I personally haven't reviewed PG&E's response to our SPD evaluation as far as what changes they've made in their approach to the GRC filing, and there may in fact be some use of that there, but I would invite the utilities to comment on any work along those lines.
Yeah, Alan, I'll say if that work's being done, it's not, we haven't seen the results of it, or I haven't seen the results. That doesn't mean that it's not being done, but I'm just not aware of it.
Yeah, I mean, if that's one, technique that could be leveraged, it could really help with that, the rigorous and more effort part of finding those homogeneous risk profiles. Yeah, that was one thing that caught my eye when looking through the evaluation report and kind of fit into this conversation. If anyone from PG&E or any of the utilities are still in the meeting, I can share this and we can talk about it. If not, we can move on to another topic. All right. Well, sounds good. So let's speaking still in terms of kind of the calculations of RSE. We saw in utilities presentations that there are different weights to the MAVF attributes, and there are also different scaling functions. So maybe this is a good time to talk about should the utilities use a uniform MAVF with the same attributes, weights, and scaling functions. And another part of that is the value of statistical life. So if I remember correctly, a lot of the utilities are using the value of 100 million, which is 10 times more than the value that is used by several US federal agencies. So should that value of statistical life be consistent with the values used by US federal agencies?
I'm happy to speak to that.
I'll take a stab. Hey, Tom, go ahead if you want to go first.
Happy to hear from you first. I've gone first. Okay.
I want to give some thoughts on the weights on the MAVF. You mentioned having uniform weights on the MAVF across the utilities. I think that's a worthwhile goal. However, the larger goal should be comparability of risk scores. That is a much more useful, much more desirable goal than having uniform weights. Now, if having uniform weights would produce comparable risk scores across utilities, that would be something we would strive for. But I'm not certain at this point yet, I'm not certain that having uniform weights would produce that type of result. So this is something we'll dive deeper into in phase 2 of the CPUC risk OIR.
Well, that's a good jumping off point for my comments. It's not just the weights that make a difference when we're talking about things like value of statistical life. It's also the ranges. So it's the combination of the weights and ranges and whether they yield reasonable trade-offs among the attributes. And so I'll just speak to the value of statistical life part of your question, Alan, first. The utilities, and I think it was noted this morning that they all come up with a value of statistical life of $100 million per life. And I want to stress, at the outset that value of statistical life, people use the acronym VSL or sometimes SVL. It's not a valuation of any individual life. It's a measure of how much society is willing to pay for marginal reductions in the risk of dying across a broad population. So we need to get that clear first. But it's the combination of weights and ranges in these utilities MAVFs, and they get to it in different ways, but they all arrive at a implied value of statistical life of $100 million. And that's about one order of magnitude higher than the value that is generally used by United States federal agencies. So for example, the US Department of Transportation, this was noted in SPD's recent report on the SEMPR ramp, the value of statistical life that the Department of Transportation uses for its analysis is most recently $11.6 million. So that's very different from $100 million. And when the utilities construct their MAVF to have this high VSL, it has the effect of overstating the safety consequence and the risk score at an absolute level, both at an absolute level and in relation to other attributes. The trade-offs among the attributes need to be reasonable and should yield reasonable results. And that's something we should be looking for in how they construct their RSEs. More generally about how differences among multi-attribute value functions, we've now seen two ramps that have presented the full discussion of their MAVF from PG&E and the SEMPR utilities, and now we just got the first preview of Edison's ramp in the post-settlement environment. Based on those MAVFs that we've seen, the only good reason that we're seeing for a difference among the utilities and how they construct their MAVFs is that the difference between gas and electric. The gas and electric reliability have different units of measurement. Otherwise, honestly, the utilities are facing the same issues and the same types of consequences from risk events, and particularly from a wildfire risk event. And so we don't really see why the MAVFs should be different. And that would lead to the comparable risk scores that Steve is looking for. So I think I feel like the burden should be on the utilities to explain why there should be any significant differences in the MAVF other than the difference between gas and electric. But if they use the same MAVFs, a comparable structure that's going to promote comparability in risk scores and comparability in RSEs, which would be extremely helpful to the regulators, to the interested parties, and I would say to the utilities in comparing how they're doing. So I'll stop there.
Okay, I'd like to divide this into three parts. So the first part is just sort of in an overarching way. These are really some of the big questions that we're facing right now. They're very important for the wildfire mitigation plans for OEIS. They're also very important for the commission and its risk-based decision-making framework proceeding that is ongoing. And it's areas of active development in both places. So I would just urge the commission and OEIS to collaborate as closely as possible to help to reduce duplication between these processes so that we can reuse some of the work that's getting done in this proceeding and in the RDF proceeding effectively. And I think that'll help everybody out. So then as far as the first part of the question, should everybody use the same thing? Ideally, yes. I very much agree with Stephen. What's the important thing is to make these calculations comparable. And I think that really is the next step for this process, is this first step is that you've done today. This is great. Identification, laying out what each of these processes, MAVF calculations actually is for each of the utilities. And the next part is to see why they're different. Now, I think we've all expressed positions regarding certain decisions that the utilities are making. I'm glad that everybody's removed caps from the ranges because we can have, extreme events. There's also the question of linear ranges. I think both TURN and MGRA have come out against PG&E's linear range, or I'm sorry, non-linear ranges. So I think we want to, advocate for that. But we really just need to see why these results are coming out so very different. And it's not easy to see just based on superficial comparison. So moving on to the third point, which is the value of statistical life. While we concur with using a federally acceptable value for value of statistical life or imputed value of statistical life, all stakeholders need to be aware of the implications of that. And that is that wildfires are expensive. So using the standard federal value of statistical life will amplify the relative contribution of the financial risk component. I suggest you look at MGRA's filing on the SEMPRA ramp. What we did is a comparison of some historical catastrophic utility fires, just using some of the assumptions SEMPRA made regarding its relative weightings and so forth, looking at the values of that would be risk from a financial standpoint, risk from a safety standpoint. We also have had it in wildfire smoke, that's something SEMPRA did, and we're looking at that as well. That will partially compensate for this amplification of the financial component, because what we're going to see as we move forward and dig more into the wildfire risk estimations is that smoke is going to turn out to be very bad. This is not good news. There's a lot more safety risk from wildfires than we even thought, and we thought they were pretty bad to begin with. So regardless, there's still going to be a heavy financial weighting. And what this makes it look like when you're actually doing the calculations is that you care more about the money than you do about the lives lost. And when you're talking about people burning to death, the optics on that are really bad. And if you look at what happened with PG&E's probation case, where Judge Alsup, based on what he saw in the Zog fire, put a whole new set of protocols on top of PG&E, because it was just, these horrible events happen to people, they're high profile, and it gets the headlines. Now, under the headlines, there are all the quiet deaths from wildfire smoke, where people with COPD or who have a COVID-19 infection are at greater risk of dying. You don't hear about that. You don't read about those in the papers. And as Tom was saying on the costs, there are a lot of ratepayers who have to make hard choices between paying utility bills and medicine and that type of thing. And so over the long term, over the broad range, you're having impacts on humans that are, not in the headlines. And that is somewhat covered by this, in this financial risk. But when we're talking about the value of statistical life, there are, you want to make sure that you don't look callous, because that's not the goal here. The goal here is to help as many people be safe and financially secure as possible. So that's our comment on that.
Could I offer a follow-up thought on that?
Please.
I do want us to be mindful of the problem, the phenomenon of anchor bias. And by anchor bias, I mean that we're thinking about this in relation to what the utilities have put out there, which is a value of statistical life of $100 million. And then to say, oh, well, if we change the MAVF so that it's close, more in alignment with what the federal agencies use, oh, we're not valuing life appropriately because we're comparing it to the anchor, the utility proposal. That's not the right way to do it. The right way to do it is to come up with a reasonable relationship, a reasonable trade-off, and strive to achieve that, and not let ourselves be influenced by what the arbitrary starting point that the utilities have set. I just want to make sure we think.
Yeah, I agree. I totally agree with that, Tom. But if you do look at wildfire, what have our historical catastrophic wildfires looked like? People can run away from fire. That's why wildfires are expensive. Their houses can't. Their houses burn down. Usually people can escape, except in cases like Paradise and so forth. So the financial losses tend to be pretty large with respect to the value of the value of statistical life of people who are injured and killed by it. So that's just it's something that we have to be aware of that's out there. And I think if you ask why have the utilities picked this $100 million? Well, they didn't. I mean, in the sense that they say they didn't. They're just using 50%. This is how the numbers come out. If you pick these particular ranges and particular weightings, then you get an imputed VSL. But if you look at some of the, and the utilities are on and speak to this if they like, Sempra, when they were putting out their ramp, they talked about, they did a sort of internal survey on how much of a outage Sempra would be willing to put up with to prevent one employee fatality. And it was like an 8-hour outage, which based on their PSPS estimations done by a couple of utilities, imputed value could be around $1 billion. So, there is this, when it comes down to a specific life, people, and it's visible, people say, we're willing to spend a lot to prevent that. And in the aggregate, that leads, it's not necessarily sustainable. You have to make sure that you're taking care of the ratepayers and so forth, and applying best practices. But there's just some optics involved that we just need to be aware of, and I think that may underlie some of the decisions that were made regarding the ranges and the weightings. And if the utilities take issue with that, that or have a different interpretation, I would be really happy to hear.
Great, and thank you for those answers and discussions.
Alan, can I
yeah.
I want to say I'm not trying to indicate that I have any strong disagreements with what Joe is saying, but I do think obviously optics is an issue. We have to be completely clueless to think that there's not an optics issue here. But I'm hoping that we can rise above that and we can think about this in a way that is based on reasoned, informed decision making, and we try not to let this become sort of a political football.
Agreed.
All right. Well, maybe we'll shift gears just a little bit here to kind of talk about the comparability of RSEs. And the first question I have is for Joseph. During the Q&A or during the presentations earlier, you mentioned that you took out some of the readability factors of 10,000, 100,000, or those, and try to compare the RSEs without those readability factors, and they were still not exactly comparable. Were there other factors that you were trying to kind of mix and match to see if there are any comparability at this point?
Yeah, I did want to bring that up because I think one thing because there's two pieces to this. One is the overall just general comparability, and then there is the difference between 2020 and 2021. And I think the big difference between 2020, when we were able to get, to make some sort of conclusions regarding there were some trends we could see. In 2021, where it was, I was just flummoxed as far as making any sort of comparison. I think the big difference is table 12 was really expanded and made a lot more granular. And I think what's happened there, and this comes down to definitions, is that there really isn't any direction or agreement on how a utility should assign its mitigations to specific line items. Because, of course, every utility does things a little bit differently, and that kind of maps onto the descriptions in table 12, but not exactly. So there's always going to be some room for interpretation. And so one thing we saw in table 12 is that some utilities would put things under one category and the others would put it under another category. And I tried to sort of re-aggregate them to make some conclusions. And I really, I failed. I could not figure out how to compare the different mitigations. And the differences were, many, were orders of magnitude between, how utilities were ranking different categories of mitigation. So I think that the next step really in this process is maybe at the broader level, not at the fine grain level, to look at categories of mitigation and how those comparative risk and RSE rankings for each utility compare. And if they're different, find out why. And based on that, we can come to the conclusion of whether there's a right way or a wrong way of doing it, or maybe there should be a standard way for this particular set of mitigations. And to sort of work through sort of from the coarse grain level to then later on to the fine grain and find out what the differences are and then drive toward similarity. And I should again point out that there is going to be in the RDF proceeding a uniformity process, although I'm not sure that's going to make the cut for phase 2. It may be that that's pushed to a third phase. So it is a timely effort. And if OEIS can help to drive to some more transparency around that, I think it would be a great thing.
Thank you, Joseph. And this next question was along that same string, but let's open it up to the floor. To promote comparability of RSEs amongst utilities, how could utilities define common mitigations and controls in similar ways? So examples such as there's variations amongst utilities in how they define overhead system hardening, enhanced vegetation management programs, and et cetera.
Well, I think I have more of a process suggestion than a I don't know, when you ask how, for me that is, I'm thinking about process, and the process I'm thinking, I mean, I guess part of it is I'm struggling with why there's any good reason to define mitigations that are given RSE scores differently, other than that the utilities have different ways of looking at things, but there's no inherent reason about the mitigations, I think, or the differences in the utilities that argues for different definitions. It's just sort of the way it's happened. It's sort of the way it's developed. And that's where it seems like we need a little intervention from the regulators to help steer us in a direction where we don't have those differences. And so the process doesn't have to be particularly convoluted. It can be as simple as either the CPUC or OEIS or both, directing utilities to get together and come up with a proposal to have common definitions for the mitigations, so that they're not looking different in the tables that they present in their WMPs and in their rate cases. That would and then put that proposal out for comment and see if we can all come to an agreement. But if the regulator set it as a goal, and if we can all agree that it's a reasonable goal, then that's a good starting point, and then we can figure out how to get there.
Hey, Tom, Steve Hayne here. That sounds very reasonable, but I just want to throw it kind of back at you, back at the interveners at large. Could the interveners, either individually or as a group, do their own proposals instead of relying on CPUC staff to do policy or technical proposals?
Oh, actually, well, my suggestion was not to put the burden on you either. Just that you put the process in motion by asking the utilities to do the legwork of trying to agree and see if they can agree, and then hopefully they can. And then it's a matter of whether once they put out a proposal, then we all comment on it.
Okay, thank you.
So Alan, I don't know if this is a good time, or do you want to wait till later to bring up what the level 4 work is doing?
Sure. Go ahead, Wendy.
I mean, it's just a little bit relevant because, we were going to talk about it later, but I think everyone knows, but we wanted to bring it up here that the CPUC has hired level 4, and they are in the process right now of doing an assessment of what all the utilities, the 3 large utilities are doing for how they calculate their MABF and their RSEs. That document is due by January 12th, a draft to us. And then we will be, we meaning CPUC and OEIS will be kind of giving them some feedback within a 10 business day period. And then they'll submit a final. Once we get that final, we plan to share it with any interested parties, the utilities, interveners and stuff. That's just basically to have like a overview of what they are doing. The next step will be that in the spring, level 4 will be basically making some recommendations. So there is a process, and we're hoping RSA staff, we're hoping that we can get this into the record in the RDF, in the risk OIR proceeding too. And then also, help with, we're trying to keep all the octopus arms in touch with each other, the OEIS work and everything. So I don't know. I mean, I'm not saying it's a bad idea to put it on the utilities too, but I just want to say this is something that is happening and in progress right now.
Is there going to be any sort of comment period for the level 4 report? And would that be associated with the RDF proceeding?
Yeah, we haven't figured that out yet. It's to be determined. So, but level 4 is definitely, if there's any factual problems, they want to know those right away, and they're committed to kind of clearing that up. But we're in the process of figuring out. Ideally, there would be some comment period.
Just to follow up, I'm anticipating that SPD will themselves be looking at that recommendations from level 4 and using that as the basis of like a staff proposal in the proceeding. And then of course, like any other proceeding, that would go out for comment at that point. If there's an opportunity to circulate the recommendations prior to that, we can certainly look into that. As Wendy said, there isn't a firm decision. But that's certainly one vehicle that I could anticipate we would have.
Great. Thank you, Wendy, for that update. We do have a Q&A question in the chat room here. Jessica, would you mind reading that one, please?
Yes, so the question is from Sarah Thomas of CPUC Legal Division. She's asking, going back to the process you were referring to earlier, Tom, she's asking, have the interveners requested the process that you asked for the regulators to act on?
I don't know for sure. If we were to do that, it would be I think in the RDF, the CPUC's RDF proceeding. I'm not the lead attorney for turn on that, but I know some of the SPD folks are probably more familiar with that proceeding than I am.
I'm not aware of any such requests.
There is a topic in the RDF regarding coming up with uniform MAVFs across utilities. It hasn't been given high priority yet, and so there haven't been any intervener proposals on that because it really hasn't become an active area of discussion yet. So this is the first forum where the question has actually come up, and thanks to OEIS for driving this and for taking our suggestions that they do so. So I think this particular forum is an opportunity, and as I suggested, I think this is really only a first step. We've done the identification phase. I think there is still data to be gathered in a comparison phase where we look and see how the utilities are coming up with such different results. And at that point, I think we can, we'll know more and can make some solid proposals. So I would suggest that this process continue in addition to whatever other process that we kick off alongside or within the framework of the RDF proceeding.
Let's see here. Jessica, do we have another question come in through the chat room?
We have a comment from Arnold Son. He is quoting from decision 21-11-009, which is related to, I believe it's a ruling 20-07-013. And he's quoting saying, we direct the IOUs to work together to come up with uniform working definitions of all subcategories of controls, and also, if needed, mitigations that are consistent and compliant with the 2021 revised SMAP lexicon we adopt in this decision. This consistency will allow for comparison of filings across utilities and across various proceedings.
Great, thank you.
If I may comment on that, I read that as being more of semantic direction, directing utilities to adopt the same language rather than identical processes or calculations. So I think, or standards for data. So that helps. It would help to have the same language being used, but I don't think that completely addresses what the differences are between these MABF calculations.
I would say I appreciate Arnold raising that because I wasn't aware of it, not being integrally involved in that proceeding, but just reading the language. And I think the topic we were talking about is common definitions of mitigation so that we don't have the problem that Joe was talking about, whereas the utilities, the energy safety puts out a template that it wants the utilities to use, but the utilities have different ideas of what the elements of that template mean. And so when one's talking about enhanced vegetation management or something, they have a different idea than what other utilities mean. So I think you can call it semantic, but I think that would help a lot if we clear up these semantic difficulties so that when we're talking about enhanced vegetation management, they're all scoping it, they're all talking about the same activities, and that removal of dead and dying trees is not separated out, or it's part of it, or there's just an agreement on how are we dealing with removal of dead and dying trees? Is that part of enhanced vegetation management, or is that something different? If it's something different, let's all do it the same way. And that is in some respects largely semantic, but we just need to be talking, have a common frame of reference for that. It's not going to solve all the comparability issues, but it would be a place where we can make progress. And it seems to be something that's directed by this language that Arnold brought to our attention.
Yeah, thank you, Arnold, for bringing that up. And well, I think that would be a really good segue into perhaps the last question that we'll go over today, which is how can the RSE calculation methodology be improved? Where can utilities reach more consistency with these improvements? So I'll open it up to the floor.
So I'll jump in. I think we've been talking about that question all day long about why do there have to be differences in, for instance, utility weights and scaling? Can we adopt a common definition of value of statistical life for safety rating purposes? Yeah, I think that's just all what the question is asking, what we've all been thinking about all day long. Is there some mandatory reason why the discount rate applied to calculate net present value has to be different? Or if it's something that's determined by the commission in the rate case process as far as coming up with this, what is it, the weighted cost of capital? Tom seems to be more familiar with it than I am, but it sounds like his experience is that the difference between utilities is very small. Perhaps for the purposes of RSE calculation, we could have a ruling that just says all the utilities are going to use an average of all of their weighted costs of capital so that we have a single number. Or if there's not that much difference in between them, they just all get to use their own weighted average cost of capital as determined for the purposes of rate cases. But I think that's a topic that could be discussed and a proposal put forward, right? And each of these factors that utilities are now choosing to be different for themselves, I think could be examined and proposal put forward for coming to some common definition of what those factors are going to be. I mean, the process of the SMAP, the process the commission has gone through to try to grapple with coming up with risk assessment quantification is an ever evolving thing. And, you know, at present, we allow a lot of flexibility, right? And the utilities kind of choosing their own, what they think makes the most sense for them. That isn't to say that a firmer set of guidelines couldn't be adopted as a result of appropriate proceeding and discussion and comment.
Yeah, a lot of that, Steve Hayne here, a lot of those comparability, uniformity type of questions will be taken up in the CPUC's risk OIR in phase 2. We will dive very much deeply into those topics. But one thing I want to warn against is the law of unintended consequences. So whatever uniformity we want to impose, we want to make sure that there are no unintended unpleasant consequences. So we have to be very thorough in our examination of those processes. And we certainly welcome any type of intervener expertise feedback in those proceedings and workshops before we can come up with any type of uniform approaches.
Joe Mitchell, I totally agree with Steve. Before we can say how do we improve it, we have to figure out what's wrong with it. And I think right now we're looking at things that look very reasonable, that come out with very different results, and we have to understand why. If we understand why, then we can make judgments as to whether one is right or more right than others, or whether there are just legitimate differences between utilities in certain areas. I think that's what the real next missing piece is just really digging down and comparing these results and seeing how do they differ. So that's our comment.
And I would say that I would suggest that we do know a fair amount about issues that we're seeing with the RSE calculations that the utilities have done to date. We know that by and large, they're not presenting sufficiently granular tranches. So that's the most important thing from TURN's perspective, because that's going to get us the information that we all need to develop portfolios of mitigations that recognize our resource limitations, societal resource limitations, ratepayer limitations. So that's really important. And we know that. I'd say not just, we would like to get to uniform MAVFs. We want to get to more defensible MAVFs. I don't think PG&E's nonlinear scaling functions for the safety and financial attributes, that's not reasonable. It doesn't make any sense from our perspective. And that's an element of disuniformity that we can deal with. And again, I would put the burden on the utilities. If they think there need to be differences in the way they structure their MAVFs, have them make a good case for that. Otherwise, we should be moving in that direction. We've talked about common definitions of mitigations and controls. I think SCE brought up issues about that. There's different utilities have different ideas for what controls mean. So let's get straight on that. It sounds like the utilities are ready to do that. It's just a matter of, again, you can call it semantics, but again, these semantic things can make a difference. And then it's also been raised common discount rates. Let's figure out how to do that, whether it doesn't have to, I think TURN has thus far been advocating weighted average cost of capital, and I'm not sure we're wedded to that, but that, at least at this point, that's what seems to be most reasonable. But that should be another thing that we talk about I hope in the SMAP upcoming phases of the SMAP or risk-defined risk-based decision-making proceeding. Okay, I'll stop there. Thanks.
And Alan, I'll just repeat again that, hopefully, but we will get some of this, a third party, level 4 will be giving us input on what they think. And, but that doesn't prevent, if the utilities want to start working together, on addressing some of these things. I mean, we all have seen issues, so we want more uniformity. Everyone does. So anyway, just want to add that.
Yeah, echoing what Wendy just said, I was happy to see that in the utility presentation that it seems like there is some level of cross-utility collaboration in the RSE world, and I don't exactly know how much collaboration is going on, or if those collaborations include the SMJUs as well, but any kind of, I think, collaboration amongst the utilities is a step in the right direction. So at this point here, James, could you bring up the slide that has closing remarks on it, please? Thank you so much. And at this point, I really want to say thank you to all the panelists today. I found a lot of value in the conversations that we've had, and also want to thank all the utilities for preparing the presentations and presenting them. I felt like it was, I felt like the utilities did a really good job with the presentation in clarity of the material, and also answering the questions that were brought on by the panelists and the attendees. So James, let's go to the next slide, please. So in terms of the next steps here, December 17th, the utilities are going to submit a report based on the directions set out in the RSE workshop presentation structure. So utilities are going to include with their presentations that they showed us today, a comprehensive spreadsheet that includes some of the risk reduction values, the net present values, some of the nitty-gritty details associated with it in a big spreadsheet. So that will be posted. Once we receive that, it will be posted to the RSE docket for everyone to read and evaluate. And also January 9th, stakeholders may provide written feedback and comments regarding today's workshop to the RSE group docket. And this workshop is recorded, and it will be posted on that docket as well, along with all of the utilities' presentations. It will take us some time to process the video for distribution, but we will get that on the docket. And if anyone has any questions on how to join the service list and receive notifications on when things are posted to the docket, please send me an email. My email is ming.wu@energysafety.ca.gov, and I will actually put that in a chat, or I feel like you guys probably know who I am, or if you have any questions, you can reach out to any staff at Energy Safety, and we'll help you get on the service list. So if there are no other questions, I really want to thank everyone's participation today. And yeah, thank you.
Thank you.